Every time it goes into my pocket, it goes off, which doesn't make any sense.
Athena, are you on? Are you mic'd?
She's mic'd, but she may not be ear-pierced.
I'm gonna get ears.
You need...
Hi.
Ears are over there.
Your mic is on?
It is.
No, there's no way it is.
Really?
Yeah.
It was green a second ago.
See, I told you every freaking time.
All right.
So stupid.
I didn't design
Wait,
it.
what
No, I
happened?
know, the mic-
Does it not like lock? Is that why?
Yeah, it's like every time you put it in your pocket, it goes off. It's so stupid.
Okay, wait. I'm gonna really hold it. Oops. Okay.
You a mic?
How did I just? I'm gonna put it. In
Sorry,
my
I can't hear. So
Okay. There.
go ahead,
Do you
Dada.
guys know where the
What's
ears
up?
are?
Yeah.
You have a mic? Can I get a mic check?
Yes, hello, good morning to the internet and associated persons on it. I'm talking so you can hear my voice. I'm doing the interview today with Max Hout. So it's going to be really cool. Lots of cool stuff.
Cool, thank you.
You got it.
Yeah, I got ears on.
Yeah, Jared's
All of them are. Right.
Oh, they're over here, yeah. Do you
right. So,
So could I just
need
grab-
your IP pack.
Okay.
Because
Whichever
you're
one.
not going to need it for the first part of the show, correct?
Me?
right,
I have
Yes.
a good one, I think.
because need to have one, and then second part of the show I can give you mine.
Because I can't hear.
Yeah, that's fine. Space at all, I don't.
Actually,
Oh, no,
yeah.
Yeah, because are you doing comments?
If he does comments, he'll need it, but he won't need it for
Use
first
that,
or
let me know
second.
if
Okay. Is anybody saying anything right now, or?
No. I mean, I don't hear anything. Yeah. Mike's breathing.
Yeah, I don't hear anything either. So,
I hear you.
I mean, I can't just hear anything. Period. At the moment. So,
No. I hear you and I hear Mike breathing.
cool.
But that's it.
Okay, that's not working.
And I like actually barely hear Mike.
Oh, cool. So if I put it in all the way, it doesn't work. But if I hold it out just a little bit, it will work, but it will pop out.
Lisa, are you going to be on for comments?
No.
No. Okay, so Jared,
Use mine.
we're just going to flip around. No.
Okay.
We're going to flip around, so you'll get the good one for comments when you need it.
Okay.
Other than that, you don't need it.
Gotcha.
Cool. Go.
Okay.
You have a chair?
Yeah,
You're good? All right, we'll walk this way so we're out of his range.
all right.
And what did you have for breakfast?
I had some eggs and
I can give you.
can't forget yogurt.
What's your favorite meal of all time?
Okay, sure. Yeah.
No, I'm thinking for 20 minutes, so I won't say
Yeah,
anything.
sounds good.
Wow.
These are my standard questions to guess. They only get harder from here, just so you know.
Best meal of all time. I like a good steak.
Good steak?
I like it. I think that's better than that. I can't
What
think.
got you into space? Like, I mean, I know you did video, but
What got me into space? Both as a kid visiting Kennedy Space Center like everyone, but most impactful was seeing the SpaceX website in 2007. Blew my mind that an entrepreneur, blah, blah, blah.
cool.
Carrie Ann, can I get you again, please?
Yeah, so what we're going to do is I'm going to have my ears for the first segment. Jared's going to have my ears for the second segment. And then we're going to have Lisa's ears for Jared in the third segment. So that Jared can have ears.
Sorry, one more time.
No, that's fine. I'm going to have my ears in the first segment. I'm giving my ears to Jared for the second segment. And then I'm going to need ears, so I'll grab Lisa's ears or whatever for the third segment.
Ears,
But,
not mics, yes.
yeah, not mics. Mics are totally fine.
Yep.
Ears are roaming around.
Cool.
Lisa, I'm sorry about that.
No, it's all good.
I definitely need at least one more of these silly things. I realize they're $1,000, but I don't care.
Everything you say, consider it public.
Okay.
How close are you?
I'm good.
No problem.
Okay, I hear.
You hear? Here, you talk.
There we go. Okay. Yes, I hear
Cool.
myself really loudly. Let me lower that. Okay. Awesome. And pocket. Hopefully nothing shuts off.
Yeah, that one should be
This
okay.
one will
It's
be
the other
okay.
one that just, I don't know why. It's so annoying.
Okay. Like cords hanging everywhere. It's like
Right?
train hanging low. Okay.
Kind of, yeah.
And now the chat. Could you help me
Yeah,
to this?
kind of.
I think it's. Which
Right.
it does.
That's why I end up having a Safari window open and a Chrome window open so that I can see it.
Oh yeah, let me separate that.
Because otherwise I screw myself up, and I don't know why.
Yeah.
Please let me know when you're ready. Mike, you ready?
Mike's been ready.
so.
Good old standby.
I know. Thank you, Mike, for being way more professional than the rest of us. I appreciate it. You set a very good example.
You're welcome, I think.
I also appreciate the cat shirt.
Yes.
Oh, thank you. Space Cat!
Yay! Cats. Cats are amazing. Okay.
All right. Yeah?
Yes. Word.
Cool.
Make this smaller. It's so big. I mean, I can't really see anyway, but okay.
Yeah? All right. I think
Yes.
I need to plug this in. Wait a minute.
we're good. Mike's got to plug something in.
Where's the?
Damn it, Mike, we're always waiting on you. Oh, wait.
There we go. I hadn't plugged in the camera here, so we were about to have that die on us.
I love it.
Careful! Don't make him mad.
I know.
Not again.
All right, ready?
All right, here we go.
Yep. Welcome to the conversation. My name is Carrie Ann, and I will be your host in this first segment of the show. With me today, I have borrowed our lovely Athena again from our TMRO Science Show. I also have a Mike, who is our rocket specialist. And behind us, I have a Dutta, who will be producing the show. I also have a Stoge back there, but don't tell anyone. Okay, so now today in News Athena, what do we have?
We have dark matter in the cosmic dawn.
Mike?
And an ISS crew returns to Earth amid space station debates.
Oh, this is going to be a good show. And then in our second segment, Jared actually will be back, and he's going to be interviewing Max Haut from Launcher Space. And then in our third segment, we're all going to be back in some kind of configuration to talk about your questions and comments about last week's show. But this is Tomorrow Space Orbit 11.09.
Good morning. How's everything up in the sky?
always, I want to make sure I welcome all of our citizens and give a special thank you to our escape velocity citizens. These people have given us $10 or more per episode on Patreon or $30 or more a month on makersupport.com. They, of course, get their name in all 3 segments of the show. They get access to our exclusive citizen-only hangouts and, honestly, so much more. I got to pick like 2 different ones each week, and it's really difficult. They also get voting rights on some upcoming roundtable discussions, which is a lot of fun. In any case, if you would like to also become a citizen of...
Take it from the top.
What? What did I say?
You did nothing wrong.
Awesome. You were not recording.
Ah, man.
Also,
we
by
were
the
doing
way,
so good, too.
could you like keep it down over there? Because we can hear you in here.
No.
Thanks.
Can you hear yourselves through the speaker?
Man.
Yeah,
Yeah.
I've always told you that, but I have exceptional hearing, so I'm probably the only one that bothers.
Are the mics picking
It's
it
not
up?
not picking up.
No, it's not picking up on mics.
I can't hear anything. Nope.
Just, I know. Well, any of the
hi, Mike.
mics, including Mike. He can't see you.
I know, but his shirt is amazing.
Ben just doesn't want this show to go right on the first take. That's
want that
that's
shirt.
what it is.
Yeah.
This doesn't feel right. We got it right on the first take. It just doesn't feel right. Sorry.
Yeah,
Sorry.
you know what?
Seriously.
I'm done for the day. I did my part.
Oh, man. Well, we know we did great.
What's the
We know
acronym?
you did good.
Blame it on Ben.
BIOB.
Thank you. I mean, I know I can do that
like
myself, but I just want to make sure it gets it.
Ben, are you recording yet?
Okay.
Yeah, are you sure? Can I get a live picture of that to know that it's true? It does anything that I want.
There you go.
Thank you. I appreciate that.
Oh my gosh.
All right, let's do.
Welcome to the conversation. My name is Carrie Ann, and I will be your host in this first segment of the show. With me today, I have the lovely Athena that we are borrowing for our Tomorrow Science show. I also have a Mike, who is our rocket specialist, and I've got a Dada behind us who's going to be producing the show. I also have a Stoge, but don't tell anyone. Okay, so Athena, what do we have for today in news?
We have dark matter in the cosmic dawn.
That sounds awesome. Mike, what have you thrown at me?
Some International Space Station crew members are returning to Earth amid space station debates.
Oh, that's going to be cool. And then in our second segment, Jared will be back, actually. He's going to be conducting our interview today of Max Haut from Launcher Space. I had to look at my notes on that one. And then in our third segment, we're all going to be back in some sort of manner to talk about your questions and comments, concerns, complaints about our last week's show. But this is Tomorrow Space, Orbit 11.09.
Good morning. How's everything up in the sky?
All right, I want to make sure I give a huge welcome to all of our citizens, and particularly our escape velocity citizens at the top of the show. These people have contributed $10 or more per episode on Patreon or $30 or more a month on makersupport.com. They get access to our exclusive citizen-only hangouts. They get read-only access to the host channel, which is kind of an awesome thing. Actually, in parentheses, it says future reward. So, I mean, they will be at some point, I guess. They also get voting rights on upcoming roundtable discussions and so much more. If you are interested in becoming a citizen of the show, head on over to patreon.com/TMRO or makersupport.com/TMRO. It's your choice. You do you, boo.
Yeah.
One of the other things that we also like to do at the top of the show is talk about any launches that may have come up since last show. So, Mike, this is when I turn to you and ask you about launches that happened in the last week. What have you got?
Well, we had a couple launches this week, although the one that I was most looking forward to got rescheduled. But the first one that happened was on Tuesday, and that was a Japanese H-2A rocket, which launched a Japanese spy satellite into orbit, and it's going to be getting some really cool data from that. And it's part of their what they call their information gathering satellite program.
Nice.
平成30年2月10日11時午後12時34分に太陽宇宙センターから打ち上げられました。
This launch occurred on Tuesday, February 27th at 4:34 Coordinated Universal Time from the Nagashima Space Center. And it was flying the 202 configuration, which had two solid strap-on solid rocket boosters. And the H-2A can be used up to 4 solid rocket boosters for launches. Now, with this launch, JAXA and Mitsubishi Heavy Industries, the H-2A's main contractor, did not provide any live video of the webcast because of the secretive nature of the launch. But news media and other spectators near the launch pad streamed the launch online, and announcements over loudspeakers at the Nagashima press site confirmed the separation of the payload in orbit. Now, the payload was the 6th optical satellite in the Information Gathering Satellite Program, otherwise known as IGS Optical 6, and it's reportedly capable of achieving a ground resolution exceeding 40 centimeters. And it's the 16th mission flown under the IGS program to provide Japan with independent access to reconnaissance data to assess potentially hostile activities in Japan's geopolitical neighborhood, like North Korea. Now, the Japanese surveillance fleet includes a mix of different optical and radar spy satellites, and the radar-equipped craft can peer through clouds and darkness to collect all-weather reconnaissance imagery. But here is a artist representation of what the IGS Optical 6 satellite looks like, and congratulations to JAXA and Mitsubishi for the successful launch, at least. So always cool to see these H-2A launches and the 2B launches go off.
Yeah, totally. I have kind of a weird question that you may or may not be able to answer.
Yeah.
It looked like while the rocket was still on the pad just before liftoff, that it was already some like yellowing on the outside. I don't know if like that was just me like seeing something weird, or if maybe that was part of like the heat shield, not the heat shield. What am I trying to say? What's the foam on the external tank of the space shuttle, like that turned orange? I didn't know if that was like maybe something along those lines, or if you even know what I'm referring to.
I'm not sure exactly what you were referring to. I do know that the color of the core stage tank is orange because it has similar types of insulation, like what you imagine on the space shuttle core tank. But as for any sort of coloration, oh, okay. I think what that is there is just the solid rocket boosters, kind of doing almost like what we saw a couple weeks ago with the Delta IV, how it kind of starts to like burn the sides a little bit. I think that was just the different reflection of light that we were at and the initial ignition of those solid rocket boosters.
Gotcha. Also, and the other thing I was going to comment on, I apologize, I'm totally hijacking this segment, but it's mine, so that's okay. It seemed as though there was also a count up, not just a count down.
I was going to say that too. Right? I noticed that, yeah. In Japanese.
That was actually from the distance because that was what we were hearing over the loudspeakers. So actually the count had counted down to 0 and said ignition, but we didn't actually hear the sound from the rocket itself until several seconds later. That's why I kind of let it play out for a little bit so that we could hear that roar just a little bit.
Totally.
Before I started talking.
See, this is why Mike is the rocket specialist, and I asked those questions. Okay, perfect. So there was at least another launch, right? So yes, this was the ULA launch, which I saw some really amazing pictures of, where you can actually see like the plume from the rocket lifting off, and then you can also see it kind of the kickover without it being a fisheye lens. And that picture was amazing. I wish I could give credit. I apologize. Saw it on Twitter somewhere. Go find it. It's really cool. But tell me more about the launch. Mike.
Yeah, lots of beautiful imagery out there of the United Launch Alliance Atlas V rocket, which launched this Thursday. And that was launching the GOES-S weather satellite, the second in the next generation of weather satellites for the National Oceanic and Atmospheric Administration, or NOAA. And yeah, this was a pretty cool launch.
4, 3, 2, 1. And liftoff of the Atlas V and NOAA's GOES-S, a highly sophisticated weather-watching eye in the sky, to join its twin in providing better forecasts and saving lives.
Now, this launch occurred on Thursday, March 1st at 22:02 Coordinated Universal Time from Space Launch Complex 41 at Cape Canaveral, Florida. Now, the Atlas V was flying in the 514 configuration, which means that it had a 5-meter payload fairing, a single-engine Centaur upper stage, and 4 solid rocket boosters. The boosters and the core stage performed as planned, and the Centaur upper stage performed 3 engine burns with coast phases in between those burns to place the GOES-S weather satellite into a geostationary transfer orbit. Now, telemetry after the payload separated from the upper stage confirmed that GOES-S was in the correct transfer orbit with an apogee of about 35,289 kilometers and a perigee, or low point, of 8,200 kilometers, and was tilted at an angle of 9.5 degrees to the equator, which was a perfect pinpoint orbital insertion to where they wanted it to go. Now, GOES-S, and GOES stands for Geostationary Operational Environmental Satellite. It's going to be spending the next couple of months moving into its final orbital position using its own thrusters to get into a circular geostationary orbit. It's also going to be completing checkouts of all its instruments and finally entering service later this year. And when it does enter service, it'll be renamed GOES-17, providing weather coverage for the western United States and the surrounding areas, and joining with the first of the newest GOES satellites, GOES-R, which was launched in November of 2016 and is now in service as GOES-16. Now, the twin spacecraft, the first 2 of them of the GOES-R series, are carrying 6 instruments each that are going to collect a lot of different weather data in space and have much better imagers than in the past. And there's 2 more satellites in the GOES-R program, GOES-T and GOES-U, which are in assembly at Lockheed Martin's facilities in Denver, and they're replacing the previous fleet of GOES satellites, which were actually built by Boeing. And once the other 2 are launched, there should have enough coverage for the National Oceanic and Atmospheric Administration, NOAA, up until 2036. So very cool that this launch went off, and there's a whole lot more data and video and beautiful imagery that you guys can find online, but we just don't have the time for that right now.
Yeah, no kidding. Especially because I just keep asking you questions about it. No, that was really beautiful. Thank you, Mike. I appreciate it.
Love the GOES series. I just
Thank
wanted
you.
to point that out. Yeah. It was the first launch I've ever seen was the GOES-R, actually. Yeah, last November. Or the
Nice.
November before that, yeah,
Great.
2016. But
Awesome.
yeah, super cool. Yeah,
That is really
sorry.
cool.
I'll let you segue.
No. Feel free. My segues are total crap. Mike is really the segue king. Speaking of segues, so Miss Athena.
Yes.
We are talking about dark matter.
Yes.
This is something I still cannot manage to wrap my head around. So I'm hoping you can, no pun intended, shed some light on it for me.
Totally.
Okay, good.
Definitely do that. So
What have you got?
dark matter usually has been detected through only its gravitational influence, but now astronomers have actually been able to detect it through a signal that was picked up from our early universe, showing that dark matter's effect on the temperature of the hydrogen gas clouds that actually existed during the formation of the very first stars in our universe. This is known as the cosmic dawn. So between about 400,000 years after the Big Bang to about 180 million years, the universe was thought to be filled with neutral hydrogen gas. It was super dark. All that there really was just the afterglow of the Big Bang. And this gas absorbed some of the microwaves from the cosmic microwave background radiation. And just at the end of, this was known as like the end of the cosmic dark ages, or known as the age of when the first stars really formed. Radio astronomy measurements were made with an array of 3 simple radio antenna in Australia and the outback called edges. And they did this by measuring the radio waves coming from all over the sky and looked for signals of our early universe. Some of the signals have been absorbed by the hydrogen gas, where it took place at microwave wavelengths, but because everything gets stretched out to the expansion of the universe, these waves have stretched out and moved into the radio wavelengths. So these scientists were like searching the radio wavelengths, and they were looking for dips in these radio wave signals. So with the standard cosmological theory, you can predict just how much absorption of the microwaves actually occur, because that depends on the temperature of the gas. But the absorption scientists are observing is about 2.5 times greater than predicted. This suggests that the gas is a bit cooler than predicted too. Normally, they would think that the gas was predicted to be about 7 degrees above absolute zero, but it actually was about 5 above. So the gas is a lot cooler, and this observation shows that the gas had to have been giving off heat energy to something else in the universe. And the only other thing at that point in the universe that would have existed would have been dark matter, because it's the only thing that would start to form clumps, which would be the seeds for galaxies. So based on astrophysicist Renan Barkana at Tel Aviv University, the dark matter must be soaking up the extra energy and heat in the hydrogen gas in the universe. If this observation is to stand true with dark matter, then that means this would be the only other observation or measurement of dark matter other than its gravitational influence. Because up until now, scientists have only known dark matter, like I said, by its gravitational influence. And actually, a science writer, Adrian Cho, who I was listening to, it was a podcast that was talking about this subject, he said, and this is a quote, "This is a huge growth industry in cosmology and astronomy." And I totally agree with this, because if you think about it, you can trace this gas and watch as these gas clouds form into galaxies through the cosmic evolution, and you can eventually construct a map of how these galaxies will actually form. And you can then start to track the stages in which the gas clouds went from forming the first stars, and then the shape of the galaxies, and then the gravitational influence of the galaxies on the shape of the universe, and then see as we know it today. So this unexpected temperature tells us that the dark matter particles, whatever they really are, they have to be very, very light. They can't be heavier than hydrogen atoms themselves. And this is because when you have the collision of hydrogen atoms in the clouds intermixing with the dark matter particles, there's an exchange in energy and heat. So because in order for the hydrogen to cool, it has to be giving its heat and transferring it over to something else, which right now is theorized to be the dark matter particles. So if the dark matter particles were heavier than the hydrogen atoms, then you would get this effect of it just kind of like bouncing off. He actually compares this to if you take like a ping pong ball and you throw it at a bowling ball, it just totally bounces off. Where if you throw a ping pong ball at another ping pong ball, they actually have this exchange in energy, and they transfer the hydrogen heat to the dark matter. So exactly like I just said, so pretty much you have the dark matter particle, and then you have the hydrogen atom, and they're colliding, and it's actually transferring and exchanging energy and heat. So I found this research to be extremely incredible, and I'm really excited to see what is going to come out of this with dark matter. So this is a huge breakthrough, just because, yeah, for decades, we've been studying dark matter and inklings of it, but it's only been gravitational measurements.
Yeah, no, that's awesome. Although now all I can see is like a bunch of ping pong balls like coming at me.
I was trying to get like a video. I was going to shoot my own video of like throwing a ping pong ball, but I didn't want to get a bowling ball and possibly break anything.
That's kind of a lot. Yeah, no, I understand. I appreciate the effort though. Nonetheless, well, next time we'll just ping us, and then we'll hit like a ball pit or something, like a Chuck E. Cheese. Those things still exist, right?
Do that. Yeah.
Okay.
Go Dave and Buster's, like the Chuck E. Cheese sprinkles. Yeah. Get like basketball, just start throwing at each other.
I love it.
Dodgeball.
What are you doing? Science.
Yes.
Oh my goodness, that's awesome. All right, so Mr. Mike, you're going to tell us about some people and some international space stations and some earthy things.
Yeah.
That's the only segue I've got at the moment. So go ahead and hit me.
No good puns or nothing?
No, I know. I was working on it for you, and I gave Athena my best pun. I apologize.
That's all right. That's all right. Well, what I'm talking about is the Expedition 54 crew members, NASA astronauts Mark Vande Hei and then Joe Acaba of NASA, as well as Commander Alexander Masurkin of Roscosmos, have returned from the International Space Station in their Soyuz MS-06 spacecraft. And the trio landed on the steppes of Kazakhstan around 2:31 Coordinated Universal Time on Tuesday, February 27th. And that on-time touchdown closed out about 168-day and 5-hour mission since the launch from Baikonur Cosmodrome last September 12th. And during their 168 days in space, they were part of the first expedition that began a long-term increase in the crew size of the U.S. segment from 3 people to 4 people, because the Russians downgraded their side from 3 people to only 2 people. But anyway, that enabled NASA to double the time dedicated to research, surpassing 100 hours of research in 1 week.
Oh, that's awesome.
That's really awesome that they are able to do that, yeah. And looking forward to more stuff that we're going to be able to do in the future. But also during the cruise tour, Masurkin was involved in that record-breaking Russian EVA. And also there was all those major EVA tasks on the U.S. segment side over those series of EVAs that completed the replacement of the station's robotic hands, which I talked about quite a bit. And the crew also helped unload 4 visiting cargo ships, welcomed 3 new crew members aboard, and monitored the departure of 5 visiting vehicles. And once all the final farewells were complete and the hatches between the ISS and Soyuz were closed after undocking, Expedition 55 officially began with Anton Shkeplerov, NASA's Scott Tingle, and Norishige Kanai of JAXA, which is actually going to be the second Japanese commander of the space station ever. And they're going to be there by themselves until the next crew members arrive on March 23rd. Now, the Soyuz had a couple hours of free flight before it departed and landed, and you can see the crew members getting out right now. And with that landing, Misurkin's total time in space over the two space station flights stood at around 334 days, while Joe Akaba, who is a veteran of a space shuttle flight and one previous station visit, has logged 306 days in space, while this was Van de Heij's first mission in space, so all the time that he included accumulated while he was up there. So very cool mission that they were able to have. And meanwhile, while all of this was going on, the same day that the landing was happening, two senators who previously expressed opposition to the proposal to end NASA's funding to the International Space Station in 2025 sent letters to NASA and the White House asking for details about a really overdue ISS transition report. So in this February 27th statement, Senators Ted Cruz and Bill Nelson released letters that they had sent a week earlier to Robert Lightfoot, who's the acting administrator of NASA, as well as a guy named Mick Mulvaney, who's the director of the Office of Management and Budget at NASA. And what they were asking for was the status of a report on the future of the ISS that was mandated by the NASA Transition Authorization Act of 2017. And in that act, which was signed into law last year, that required NASA to develop a transition plan for the International Space Station for shifting its operations from the current regime to one where NASA could be one of many customers of a low Earth orbit non-governmental human spaceflight enterprise. So with that, they were looking for other possibilities as well, such as extending the operations at the ISS in the current way that we're doing it from 2024 to 2028 and even beyond 2030. And that act required that NASA turn in that report by the beginning of December 2017. So here we are. It's now March of 2018. And Cruz and Nelson said that the language in the 2019 budget proposal seeking to end NASA's funding to the ISS in 2025, remained really concerning to them and has led them to seek the status of the transition plan and find out exactly what is going on and get, any rough drafts and any information that they possibly have for it. And one of the quotes that I wanted to talk about in this letter that they had is that they said that while we have strong proponents of the U.S. commercial space sector, prematurely ending direct U.S. government funding of the ISS could have disastrous consequences. The future of the International Space Station should be determined by the emergence of a viable and proven commercial alternative and the needs of our national space program. So I'm very encouraged by their support and the kind of fight that they are putting on already to the idea of canceling funding in 2025. And I'm really looking forward to what sort of support for commercial alternatives or even extensions to the ISS might come about, like Bigelow Aerospace or even Ixion, which is studying the idea of having the wet workshops, reusing a upper stage core stage, the fuel tank, and turn it into a habitation module, kind of like what we did with the Skylab program. So I'm really encouraged by this, and there's a lot more support. And with these people, especially Senator Cruz, since he's on the Science and Space Committee, they will not let things end without a fight. And hopefully we're going to see the ISS continue on for many years, since people from Boeing have been weighing in and giving lots of data about what the expected lifespan of the hardware is and when we would actually need to do a retirement. And I'm hoping that we can push things out as far as possible. So yeah, that's your ISS update for the week.
I love it. That's totally what we need. So Mike does launches, Mike does ISS updates. Like, we just need your own little corner, I think, right?
Rocket and human spaceflight stuff. Just send all that my way.
I love it. I love it. I love it.
You should have your own space station.
I know. Oh, yes. A hologram can go anywhere.
I want to have an orbital. I want to be an orbital garbage man and have a recycling station. I want to go up and wrangle as much space junk and defunct satellites as I can, and salvage as much hardware as possible, and cobble together some new stuff and deploy out some new satellites out of the stuff that I got.
You'd be like the guy on the beach with like a metal detector, except you'd be in space.
Yes.
Giant metal detector.
Maybe it'd be respectable. I don't know.
Right?
I don't know.
Oh, that's awesome. All right, so then, Miss Athena, you're going to be closing out the segment with a bad day. This is a terrible headline.
I know, it sounds horrible, but it's actually
right
like kind of cool, but not. It's Proxima Centauri. So our sun's like closest neighboring star, other than obviously like our own sun is the closest star to us. It had a stellar flare. So our sun has a lot of like solar flares, which is just like a big burst of like energy, an explosion of radiation. But this is the first time it's been observed of Proxima Centauri. So this led to astronomers actually researching the potentiality for life on the exoplanet Proxima b, which orbits Proxima Centauri. About 20 times closer than the Earth orbits the Sun, Proxima b orbits very closely to Proxima Centauri. And with this intense stellar flare that was recorded recently, it would have blasted Proxima b with about 4,000 times more radiation than what the Earth gets from a solar flare. So at peak luminosity, this flare was 10 times brighter than our sun's largest flares when observed at similar wavelengths. And Proxima Centauri's stellar type is known as an M dwarf, which are most common in our galaxy, yet they're not studied that often in these wavelengths that this was actually studied in. When this flare actually happened, it caused the brightness of Proxima Centauri to increase by about 1,000 times in only 10 seconds. What causes a stellar flare to happen are excited electrons in the star reaching acceleration rates close to or at the speed of light due to a shift in the magnetic field of the star itself. And then when these electrons interact with the plasma that makes up most of the star, it results in an eruption of stellar emission spanning the entire electromagnetic spectrum. So astrophysicists believe that due to Proxima b's closeness to Proxima Centauri, it's likely that it was blasted with so much high energy radiation that if there was an atmosphere or any life at all, this blast would have totally evaporated either the atmosphere or oceans and would have sterilized the surface. So if this stellar flare is a common occurrence for Proxima Centauri, this may suggest that habitability would involve more than just being the right distance from the host star to have liquid water. Right now, actually, this is a region called the Goldilocks zone. Or also like the habitable zone, which is like a certain region that needs to be in orbit around its star for life to possibly exist. It also means that if this planet has any life forms, they would have to find a way to actually survive these harsh bursts of radiation. So I wonder, like if this takes out the potential for Proxima b being an exoplanet with life. Oh yeah, this is a really pretty image of an aurora, also known as like the northern lights that we actually experience here on Earth, which is interaction of the electromagnetic particles with Earth interacting with like a solar flare that actually comes from the sun. So it's super pretty, and
it is.
We probably don't experience that on Proxima b because the solar flare was so intense.
Right.
But yeah, but I think if they actually do find a way where life forms can exist through these really harsh conditions, that's like that'd be crazy. That'd be dope. Like, that'd be really cool. But there's a high chance, too, that if there actually was any life similar to, like, what we would be on Proxima b, that it might have actually completely gotten, like, evaporated from this solar flare. So I know that's why I titled it Proxima b. It had a bad day.
Yeah, totally. Go ahead, Mike.
Correct me if I'm wrong, though, and any of you in the chat room, if you know the answer to this. Didn't we just discover Proxima b just a couple of years ago? So we don't even know yet what its composition is and whether or not it has a strong magnetic field like Earth. I mean, even though it's being exposed to these solar flares or stellar flares that are 4,000 times stronger than what Earth is happening, if it has a strong enough magnetic field, I mean, there could be a chance, that trite saying, life finds a way, and maybe even there is life on there that's similar to something like tardigrades or something that don't need to worry about that type of radiation. Who knows?
I was just Googling tardigrades. Exactly. I was like, it's that water bear thing. What do we call it? Oh, tardigrades.
Yeah.
And for those of you watching Star Trek Discovery, no spoilers. That's really interesting. I had a very similar thought. Good point.
Yeah, no, you're definitely right. We don't actually really know.
Rule it out yet.
Yes, yeah, word, exactly. So we don't actually really know as far as like the composition of Proxima b of this exoplanet, and yeah, if it has like a super strong electromagnetic field, that would be great. Because then the auroras, like looking at that image again, like can't even imagine what they would look like on this planet. Totally. And then its little tardigrades might be super happy.
Is that a big differentiation between what we here on Earth call a solar flare versus what you were defining here as a stellar flare? or are they kind of one and the same? It's just it's not our sun, so we had to give it a different
Exactly,
name.
it's the name. It's just like saying solar system and planetary system. It's just that we keyed the name solar or the sun as our star. We don't just call it a star; we call it like our sun.
Right.
And so that's where we use the term solar flare as opposed to stellar flare, but it is essentially the same exact thing, just different terminology.
All right. Just want to make sure I didn't know if like one was like way bigger than the other.
Right, yeah,
Like-
this one was really big, but you know,
Right.
but it's the same exact category.
All right.
Yeah.
Awesome. See, I learned something. You watched me learn. Which means I'm probably done for the day. In any case, what we're going to do now, Carrie-Ann can only learn so much, man, and then it's got to, otherwise it gets pushed out really quickly.
Not enough now, huh?
Yeah, exactly. So what we're going to do is we're going to take a little bit of a calendar break. You get to see all of the launches that Mike hopefully will be talking about next week on the show. And when we come back, Jared will be conducting an interview about launcher space with Max Haut. Stay with us. More tomorrow, coming right back.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled on some expectation. This girl's a fascination. And nothing in her way will keep her from her destination. 'Cause she's fire walking. She's fire walking. When it's hot, she keeps on moving. Through the heat, keeps on improving. Yeah, she's fire walking. She's fire walking to be free.
Hello and welcome back to Tomorrow. Now, before we get started in our interview today, I just, of course, want to thank our citizens of tomorrow, specifically of our escape velocity variety. And, of course, how could we forget our orbital citizens as well? These folks gave us $5 or more per episode on Patreon or $15 per month or more on Maker Support. And they give some really good goodies that if you actually go onto patreon.com/TMRO or makersupport.com/TMRO, you can find out what those goodies are, and you can help crowdfund the shows of tomorrow. So I am super excited today because I have got you, sir, Mr. Max Haut of Launcher Space today, which this is going to be a really fun interview because I've got a ton of questions, and of course we're going to talk with our chat room today as well about that. So welcome, of course, to.
Thanks for having me. I love this show, so
excellent.
It's an honor to be here, and I look forward to talk about Launcher with you, Jared.
Excellent. So right out the gate, Max, I kind of want to ask you. So what kind of is your background? Because you didn't really start in space, but you ended up moving into space. So kind of what's your background for the folks who may not
my
know
background, the last 10 years, I started a company called Livestream, which is a live video platform. And more recently, towards the end, I actually founded a camera called Mevo, which is probably, I might be biased, the best live streaming camera there's out there. We made more than 100,000 of them, and gave me a lot of grounding in building teams of electrical and mechanical engineering, things I didn't know in the past. So yeah, I come from the video and internet industry, and now Livestream has actually found a new home with IAC Vimeo that acquired it last year, and have the chance to be able to do something new and something I've been dreaming to do. In a market which I think is getting, it's very difficult, but it's getting easier and easier. So that's how I got to space. So for me,
excellent. So if you could tell us just a little bit about Launcher, and what you guys sort of like, what was the initial thing that kind of got Launcher going for you guys?
So at first, actually, when I started to decide to start my new career in aerospace, I was looking at doing a CubeSat startup. And the more I dug, I realized that launch, even though obviously we launched for small satellite, we at the time at Rocket Lab getting pretty close to hopefully reach orbit. I realized that launch was still not resolved, and there was still a big opportunity there. So what we are doing, we're building a relatively small orbital launch vehicle to deliver small satellite. But we have two Ps that are I think unique from all the competitors you might see out there. The first one is right out of the gate, we're proud of our 10-year timeline. So we have a 10-year timeline to be commercial. We've probably test flight 7 years, 8 years in, and we are about to have our first anniversary in a month or so. So we're nearly minus 9 years of that timeline. The second piece, because of that timeline, we have an approach which is engine first. You see a lot of these startups trying to build a team of 100 people and going at every subsystems you need to build a launch system. There's about at least 100 systems that you need to build with small team, from fairing, stage separation, guidance, obviously engines, and so on. And we think that it's a very risky approach. So because we have more time, because we have a thesis that the market is still going to be very exciting in 10 years, we are focusing exclusively on building the team and the engine, and everything else will come once we have not a demonstration engine, or flight-ready, LOX-rich stage combustion, 22,000-pound engine, which we hope will be in 3 years. So we just started development of that engine. We developed our first development engine last year, and we have 3 years to finish the development of that engine with a team that will be less than 10 people, a range of partners, and we believe less than $10 million.
So what's the advantage? Because it sounds like you're taking sort of like an incremental approach to building your small launcher. What's the advantage of an incremental approach as opposed to sort of like some other companies that have kind of come in from all sides and attacked it that way?
Well, first let's take a step back, right? Only 11 countries have delivered anything to orbit. Before a month ago, only one VC-funded company had done it, which is SpaceX, obviously. And now we're super excited with Rocket Lab being the second one. Proving that, it's a good thing to invest in launchers. SpaceX is not a one-off and not a fluke. So if you look at it, it's extremely hard, extremely rare. And, the engine really defines a lot of, everything about your launch vehicle and so on. So if you have a really long view of the market, if you believe that it's not a winner takes all, and you're able to take a realistic timeline, then you can basically focus on your engine. Now, if you look at it, if we were a government contractor, 10 years to build from scratch a launcher, you actually get laughed at. That's extremely aggressive. Rocket Lab, if you think, we think that their engine, they kind of locked it down in about 2010 and first flight in 2013. It took them 8 years, and they're not yet commercial. They are, they reached orbit, but it probably will take them another year to be getting the cadence and being commercial. SpaceX, it took them 6 years to get Falcon 1, and then they scrapped it after 2 flights and focused on Falcon 9. And it took nearly 10 years as well. So 10 years is by no means an easy timeline, and we think it's great because you can really align your engineering team and your investors. It acts as a great filter. Of course, it'd be great if we beat it. If we meet it, it'll be amazing. And that, that's the differentiator. And you see a lot of people out there saying they'll be orbital in a few years. And we'll see. We hope they succeed, because we certainly want as many companies and investors to succeed in this space, not to a lot of investors to lose their money, for example. So.
Yeah. So we've actually got some footage that you guys provided. Let's go ahead and take a look at that as it comes through, because this is just some incredible work that you guys are doing. So what are we looking at here?
So this is engine one. So the company started in May. We had a team of 2. We now 4 plus. Obviously, we have some partners for the new engine. We have external consultant. And in less than 8 months, we developed a test site, a test stand, all the electronics. It can fire a pressure fan engine of about up to 1,000 psi. And we've also mastered safely the use of liquid oxygen and kerosene. So this is our development engine. It's 3D printed in just 3 parts. It's very small. It's 500 pounds in thrust. I can tell you that if you come and visit us at the test site, we get scared sometimes. It's amazing. It's tiny, but you get very small. It still locks in RP1. So it generates 500 pounds of thrust. It has regen cooling, and it is 3D printed with an augmented spark igniter. So in less than a year, we built a team that was able to build all the systems in software, hardware, and obviously design and build in 3D printing an engine with our manufacturing partner. And we fired it successfully in December. Right now, we're finishing that test campaign. We're getting longer and longer runs. We obviously optimizing the performance, but this engine will not fly. It allowed us to start building the team, to learn about 3D printing. The cooling, for example, the cooling channels that you have, the kerosene actually flow through the body of the chamber to cool it, as in every orbital liquid engine. And that technology in mastering these tiny channels and 3D printing them, that applies, for example, directly into our flight engine, which is a 22,000-pound engine. So it's about 10 times smaller than a Merlin 1D of SpaceX, 4 times bigger than a Rocket Lab Rutherford, and 40 times bigger than this in terms of thrust.
Yes.
There.
So what's so you were talking about doing 3D printing for your engine. What's the advantage over traditional manufacturing methods to have 3D printing involved?
So I'll start with the disadvantage. The disadvantage is that you're limited in volume. There's no very big DMLS. It's powder bed, laser, 3D printing. You're limited in volume. The other disadvantage, you can only print in one metal. Actually, if you look at all of the orbital liquid flight engine, they typically have a liner in copper, which has great thermal conductivity to move all of the thermal energy into the coolant, which is in the wall. And then they have like a nickel alloy type bracing around. So these are the disadvantages. The advantage is that if you're building a traditional chamber, like SpaceX actually started with Merlin 1A with a carbon fiber ablative type chamber, which they quickly switched to a traditionally manufactured chamber. You basically have to, the tolerance in creating the liner and the outer shell, and then the brazing that you have to do to bring it all together is absolutely insane in terms of investment in jigs and infrastructure and expertise to build them. So, building a chamber traditionally of any size, you're talking about, tens of millions of dollars probably of investment right off the bat, and you can't call a chamber manufacturing shop and get one ordered. 3D printing, you can. There are many. We use EOS machine, the M290 and M400. It's a multi-billion-dollar German company, and you can either buy it or you can actually work with a number of vendors on the East Coast and the West Coast, and you can print your part. There are disadvantages. That's why Rocket Lab, had to stay within a form factor, especially in their their design cycle, which was in the early 2010. And it's not as high performance given the lack of copper in the liner. But certainly, we were able to make an engine investing well under $1 million for everything, and traditional manufacturing wouldn't have been able to do it. And Musk did it with SpaceX, but let's not forget he started with $100 million. So he was able to invest in in all the expertise and the machines to make traditional chamber for Merlin.
So Manafsen in our chat room asked what technology you're using. So there you go, Manafsen. That's what they're using there.
Yeah, and it's Inconel 3D printed with spiraling channels in the chamber.
Excellent. So BEF in our chat room has a question for you, which they're wondering what your engine cycle is.
That's interesting. So our whole approach. So this year we did engine one, as you saw. We obviously raised capital. We built a test lab, built a team, but we also defined our roadmap, which is our vehicle and obviously our flight engine, which I mentioned. And our approach is to go for the highest performance engine we can 3D print with our team, which is growing, in under 3 years for under 10 million. And we arrive at a 22,000 pound and LOX-rich stage combustion. Now, if you look at cycles, you have pressure fed, which is the simplest, but you can't get to orbit. You then have electric, which is actually an amazing hack that Rocket Lab was able to do. But there is it has a problem, is that you have to carry these batteries, and whether the batteries are 90% charged or 10% charged, they have the same mass. So actually, electric propulsion turbopump is easier, but it's lower performance, and they actually were able to dispense of the batteries on the second stage. Then you have open cycle, which is what SpaceX is using, and then on the higher performance end, which is actually what the Soviet era has mastered with the RD-180 and so on, it's stage combustion. So we believe we have the right team, and there are team members that are joining us this summer to attempt a stage combustion engine, which will bring us probably the highest performance you can build in a 3D printed engine. And you can see, BE4 and Raptor are moving all to stage combustion. So the US is also moving to that type of cycle. So that's probably the riskiest part of our roadmap, is this type of cycle, which is famously known as the hardest to master.
Yes. And just to kind of reiterate, because one of our chat room people, CFIT, is asking, you're using turbopumps. So you guys are using turbopumps for yours?
No, so I mean, engine one is a 500-pound prototype for the reason I've mentioned. So engine two, we actually are, most propulsion startup or launch vehicle startup start with the chamber. And actually, if you build a pump-fed engine, you should really start with the turbo pump. And within the turbo pump, you should start with the liquid oxygen pump. Our liquid oxygen pump is to go under 30,000 RPM, 30,000 rotation per minute. It has to discharge about 25 kilogram of liquid oxygen per second. These are extreme conditions, given that liquid oxygen can basically explode at any point in time if you have any friction. So we're starting with that. We've signed our partner contract to develop it and to test it. Our pump will be 3D printed, and we hope to have the flight-ready pump by mid next year tested. So yes, it's a traditional turbo pump, one shaft, turbine, pre-burner, one liquid oxygen pump, two kerosene pump. And the pressure is nearly 5,000 psi. So this is not the chamber pressure. Chamber pressure is about 100 atmosphere, but the pump outlet pressure is about nearly 5,000 psi, which is a big part of the project to successfully build this engine.
Yeah. So Factor from our chat room is actually asking sort of about your 3D printing equipment, which is, are you working with other manufacturers for spin-off ideas to kind of help make something for a launcher on the side?
We want to pick our battles. I think there are some startups that are building their own 3D printers for tanks and other things. We want to rely on the billions of dollars of investment that what's being done by many of the leading companies. Right now, we think EOS is the right company. So right now we're using off the shelf, but there's actually a lot of craft in using these machines, especially for doing internal channels as we have, and we have a range of partners that we work with. Actually, for the E2 engine, we need a larger 3D printer that's available today. But because we're starting with the turbo pump, we only need the chamber and the nozzle right at the end of our development process in about 2 years. So we have the bet, we're making the technical bet that machine will be available by then. But we're also having discussion about customized machine. But fundamentally, it's the same machine. It's maybe a bigger form factor, but we'll see. That's for later. For 3D printing a turbo pump, which some part will not be 3D printed, machines today available are, the technology is right there. Some parts will be traditionally manufactured, but we don't have to wait for a bigger machine. And in your development process, I don't know if you heard before, had a power pack failure, and right there. That's really the first step, and it's probably 70% of the difficulty of the engine is to have your power pack, which is basically your turbo pump with some valve, running nominally without exploding, and you actually don't have a chamber and a nozzle. And once you get that running and you're satisfied, then you can move on to the full assembly, which is the chamber and the nozzle, for which we don't yet know how we're going to make it, but we'll figure that out.
Yeah, and to go back to our chat room, Factor is asking if you're finding newer or better designs using 3D printing, or are you guys kind of sticking with the tried and true methods of rocketry?
Let's look back at SpaceX. They did innovation with the Pinto injector with phase shutoff. But Falcon 1 and Falcon 9 is a traditionally manufactured launch vehicle. And then once they got there, right, they did the biggest probably innovation in the industry since the industry started, which is landing rocket and reusability. So we want to pick our battles and really start with the basics, and I think it's accepted that you can use 3D printing, and it's been proven now with Rocket Lab. 3D printed rocket engine have gone to space. And so in terms of design pattern, we don't think we have the capital or the risk to basically try to go down these roads. I think other people need to try that. So our liquid oxygen pump is traditionally designed, and we make 3D printing fit our requirement instead of invent a new 3D printer, a new design for a liquid oxygen pump to fit 3D printing. I wish we could, but I don't think it's reasonable from a risk point of view.
I kind of want to ask you about what it's like to be in an aerospace startup, because you guys are 1 year in to it, and that's kind of, for some aerospace groups, that's kind of infancy of what it's like. So, what's it like being 1 year into the establishment of yourself?
What's amazing, I'll tell you. I remember being in my kitchen with my wife, and I've been dreaming about doing this forever, and things were changing with live stream, and suddenly I decided, I got the support of my wife. Okay, let's do this, right? We had zero team. I knew nothing about it. I still don't, if you talk to me in 10 years, I'll tell you that at this interview, I knew nothing about it. It's a journey of learning. And we went for it, and we didn't raise any capital. So, what's been really amazing, so today we've obviously fired an engine, we built a team, we raised capital. I'm here talking to you about it, and we've defined our whole roadmap. And one of the most, exciting thing is the amount of people that want to help you. You talk to 3D printing partner, you talk to people that make pumps, you talk to, everybody wants to work on this thing. And, some people you meet, they're like, oh, another rocket startup, facepalm, it's crazy. There's so many. But if you really look at the opportunity, maybe around the world there's 100 startups with on average 20 people working on it. That's like 2,000 people around the world working in, private VC funded new launcher company. And if you look at the opportunity, we think it's so little. So, back to the experiment, if you look at the internet industry, you're fighting to get any engineers. You're trying to sell them your dream, our video platform. You are fighting against Google, Facebook, and so on to hire everybody. You now look in aerospace. That shocked me. We've never done any advertising. We don't have any job opening. We get 3 or 4 resumes a week that just show up, from experienced people to new graduate. And if you look at it, there are thousands and thousands of graduates of aerospace that are dreaming to get hands-on with building rocket engine and vehicles, and they all want to work at SpaceX, but SpaceX is hiring 3%, 4%, 5%. So there's still all these other ones that are looking for home, and there's not that many startups. Back to my comment, you could think there's a lot, but there's not that many people doing what we're doing and that are hiring. So the most excitement, so back to your question, is the amount of support, and then the amount of talent that want to join. And it's more the limiting factor is our budget and our funding, not the amount of talent from experience to graduate that want to get hands-on with this.
Yeah, that's just, when you frame it like that, just the value of people coming together and really working towards a common goal. That's just a fantastic way of doing things.
I mean, and everyone that knocks on your door, they want to build a rocket, right? So, in startups, you have this dream, this idea, this app, you kind of have to convince people that, but there, one of the great things is also the culture and the desire is there, from before they send you the resume. And so that to me has given me more and more confidence that it's a matter of cash and it's a matter of the market. We have a thesis that maybe 10,000 kilos a year of CubeSat will be launched in 10 years. And that all the startups that are today, maybe only 5 will succeed and be around in 10 years just by the, startup pipeline. Not everybody succeeds. And we think it's still widely, inappropriate the amount of capacity that will bring to deliver what's to come, which will be really all of these CubeSat startups are really from new generation of entrepreneurs that are coming out of college and being backed by investor. So this is all to come, and that's really why we're taking the long view to be there with the right product at the end of a reasonable timeline.
Yeah, and to kind of talk about that future a little bit, Laura in our chat room is wondering which part of the market are you building for? I guess sort of what's the payload mass that you're going to be launching to low Earth orbit?
So we have a paper rocket that's configured that use 4 of our E2 engine. That's a 22,000 on the first stage and 1 on the second stage. It can take 300 kilogram to low Earth orbit. About 100 kilogram to 1,000 kilometer orbit. So that's what we have today. The reality is that the final configuration of our vehicle will be done with the latest market information and when the engine is done in about 2.5 years. So we might end up with a smaller one or a bigger one. With the size of engine we have a lot of flexibility. Our goal is the CubeSat market, and we hope we can develop a big enough launch vehicle so that we can carry single units of the internet constellation. That's the sweet spot. I'm sure everybody here knows, but when I started Launcher a year ago, there was 20,000 proposed new internet constellation satellite to be launched in the next 5 years. Just since Sputnik, only 5,000 have ever been sent, and 3,000 are operational. So that's an insane number. That's now grown to 30,000, I think. And obviously, we've had Starlink, the first real evidence from SpaceX Starlink a week ago. If that's really true, if that will happen, and you look at the launch industry, the big launcher that we see every week, with Mike covering, the last 20 years has been 350 tons of payload every year, no growth. But if these internet constellation will happen, and I don't think 30,000 will happen, but if they will happen, this industry, the large launcher industry, has to go probably 5x. So if we can get some of these, most of them will deliver on Falcon 9 and Soyuz and Ariane in batch of 10 or 20. But if our launch vehicle can capture just a single unit of these, as well as the CubeSat, we will be in an amazing place. That's where we hope to be. But maybe the CubeSat will be enough. We will see.
Yeah, and kind of to sort of talk a little bit about ways to kind of lower cost of access to space. BEF in our chat room has a question: if you're planning on using reusability to lower costs, because I know a lot of small sat launchers aren't looking at reusability; they're just kind of expendable. So is that? And I know reusability is a really hot thing, right now with the actual flight proven boosters being flown. So is that a thing that works for you guys, or is it kind of a little bit of a challenge?
There's a few challenges. First one is you have to walk before you run. And we're making sure that obviously all of the technical choice we make in the architecture could be used for reusability, from the gimbaling to the engine architecture. But the problem with small launcher is that the payload mass is a very small percentage of the entire vehicle. For us, under 1%, probably for Rocket Lab, under 1%. So if you look at a Falcon 9, which can take, 20 ton to lower Earth orbit, most customers don't need the full load, and they have enough capacity to put, tons of fuel to come back. If you look at our vehicle, we have 300 kilogram and we have 30 tons of fuel. If you have a small payload, let's say, 50 kilogram payload, that only gives us another, 250 kilogram of fuel to do reusability. So there is a flow between reusability and small launch vehicle. There is a conflict. Maybe there's a sweet spot with slightly medium-sized small launcher that will be able to do it. We will see. But coming back to the market, people don't realize, but Rocket Lab, which is going to open the market, is about $60,000 a kilo. SpaceX is under $5,000 a kilo. So it's not about reducing the cost per kilo. If you are Planet and you're making a 3U CubeSat, you find that it costs $250,000 to send a CubeSat. You don't need it to cost $200 or $2,500. It'd be great if it was cheaper, but what you really need is the ability to send them when you want in custom orbits and in batch. And right now, the only way to do that is to buy a $60 million, the cheapest, before Rocket Lab existed, the cheapest launch vehicle is $60 million, which is Falcon 9. And a startup like Planet or the smaller versions of that, they can't buy that. Now, with $5 million with Rocket Lab, they could basically launch, tens of them and actually fund the 5 million launch. So it's really not about the price per kilo at this point. It's about the price for the whole launch vehicle. And reusability is not a factor yet, but it will be. I have no doubt that if we're going to be a 30-year launch vehicle timeline, we hope to be 100 years, whatever. We're building a long-term company. There is no way we will be around if we don't crack reusability at some point. That's for sure.
So right now, the small sat launcher market's kind of in that launch on demand kind of area.
Piggyback, you
at the
mean?
moment.
Right, share.
Gotcha.
Yeah, right now, if you look at it, 2 years ago, only 100 CubeSat went to orbit. And that's because of launch capacity. Last year, thanks to PSLV of the Indian Space Agency, in February, they sent about 100 at the same time, or more than 100. 300 went up. We'll see this year and the year after, but I think that number, as I mentioned, can easily get to 10,000 kilo within 10 years. Just by the fact that VCs are getting involved, that you can now start a satellite company with $10 million, you can launch a demo constellation. Before, $100 million to launch, $200 million to build your satellite, and that's just for one. So unless you were a multi-billion-dollar media company or a government agency, you were not launching satellites. So the full effect of VCs, that obviously there's a huge VC network that has created Silicon Valley and tech as we know it, can now have departments, that they call frontier tech, and they can invest in launcher companies or CubeSat companies. That full ripple effect, which also create entrepreneurs thinking about what they could do with this platform, we've yet to see, the result of that. And Rocket Lab getting to orbit is a key milestone to make it possible to launch and to forecast at a given price.
So to kind of take a comment from Twicked in our chat room and to kind of paraphrase it, which is that there are a lot of small sat companies that are coming out, and it kind of almost reminds a lot of people of the internet in its infancy, where you had a ton of companies and then a really big bubble developed and it popped, and a lot of companies didn't end up surviving that. So what's the edge that you guys have that would help you survive something like that?
Oh, you mean a lot of launcher companies versus satellite companies?
Yes. Yeah.
The bubble is really a question of the demand in the market, right? In terms of, will there be satellite companies, and will Rocket Lab and others fulfill completely that demand? We have the long view. It could be a bubble. We're not sure. But we're certainly betting that it's not, and that a lot more application can come out of low Earth orbit. Just think about, let's talk about Starlink again. Imagine that this constellation is up. If you launch a CubeSat right now, you can have 9.6 kilobit of internet connection with Globalstar. That's like the speed of a 1990s modem. Or you can beam back to ground station and broadcast, your image and so on. It's very proprietary, it's very expensive, and so connectivity back from this CubeSat is still a big problem. Now, fast forward 5 years, when Starlink is there, you can put a little module and you have gigabit internet connectivity always on, because you're communicating with these SpaceX or OneWeb or who else, satellite that are just above you. So now you have launch resolved, and you have obviously the miniaturization of satellite, which has already happened, and you have connectivity there. Maybe we'll see storage in the cloud. Maybe we'll see compute. Maybe we'll see live streaming from satellites. So I think the double effect between the miniaturization and the connectivity being resolved, with launch being resolved, I think we don't believe it's a bubble. We're bullish, but there will always be, at the end, the last 20 years of the industry, other than SpaceX arriving, SpaceX actually didn't grow the satellite market. It took dollars away from some people or payload from some people and sold it for less. So maybe even from as a market, a dollar point of view, it's a smaller market than it was thanks to SpaceX. Now, next 20 years, we see we're in 95. Maybe there'll be a bubble on the way. But it's certainly, the start of a new platform. That's certainly our view. Some people will tell you it's going to be the same, and all these small launcher startup will die, and But there's always that view. But we'll see.
Yeah. And Madison in our chat room is asking, what kind of roadmap do you guys envision? So how's the future looking?
So as I mentioned, you have the next 3 years. So last year we achieved all of our objectives with Engine 1. Funding, team building, and so on. Next 3 years, we're building our engine. So that's the roadmap. That's the engine I mentioned. And we're not building a demonstration article. We have to get to a flight capable engine. Maybe not fully qualified, but nearly. Then we'll need some substantial fundraising. I think in terms of the funding we already have today and the partners, getting the engine done, we think we've got that covered. But then, growing and building the launch vehicle, that will take probably about $100 million. We only will get that type of funding if A, we build an amazing engine with an amazing team, and B, our prediction that Rocket Lab didn't take the whole market, right? Or that it's a bubble was right. And there's still a backlog, and there are still VCs wanting to get involved at, lower valuations. So, if we succeed at that funding event, which will be in 3 years, then we'll grow to 100 people, and we'll have to get all out building a launch vehicle by 2026.
And to kind of go to our chat room again, to kind of combine two questions. Madison has the question of where your company is located, and then CFIT also is asking if you have a proposed launch site for your vehicle as well.
So the way we look at, we're located in New York, in Brooklyn, for our design office at an incubator called New Lab, and we have a test site at an old Grumman facility on Long Island. What's really interesting is New York there's a few amazing company, for example, Marotta, that supply all the valves to SpaceX that are around. There's some company in Connecticut, but right now the aerospace industry is nothing like around here. But back in the Apollo program, this was the center of it all. You know, the LEM was made on Long Island. So we think it's a great edge because there's a lot of engineers that want to be in New York around their family, and they don't necessarily want to go to here in LA. So yeah, that's where we're located and growing. So I forgot the second part of the question.
The second one was about a proposed launch site.
Yeah, so the same way we think about, you see a lot of startups doing pre-booking and signing deals with satellite. At the end, launch delivery is a matrix of availability and reliability, but it's a market. Of course, there's 2-3 year notice for integration and so on. But if you have an orbital launch vehicle, you don't need signed customers now. They will come, if you price at the right price. The same goes with launch site. We probably need, 3 or 4 years before we launch. We need to start securing a lease and building the facility. I hope it will be Kennedy Space Center. It might be Vandenberg. It might be Wallops. Ultimately, it's any launch site that the FAA and the U.S. government will give us access with KSC being the ideal one. That's probably a problem for 4 years from now for us.
I just want to say it's really cool that there's literally a launch company in Brooklyn, New York. That is like super cool. That is like the last place I would think of where I would have ended up figuring out where a launch company would come from.
If we did it in Long Beach, we would be competing with everybody else. And there we are, there's a great heritage. And, literally 1 out of 5 resume is either an experienced or a graduate engineer saying, I want to be in New York. And, well, you might be small, but you're the only company building rocket engines. Yeah. So ultimately, we're there because I'm there with my family, and we started there and we considered moving to Mojave and so on. And we were like, if we can find a test site, maybe it's not a crazy idea. A year forward, we think it's great. There's a lot of capital there, a lot of press. We differentiated for the recruitment, and we have found a great test site partner. And local administration love it because there's all this agenda of bringing aerospace back to Long Island and New York, and we're part of it. We're small, but maybe we won't be small in 10 years.
So for launcher itself, what is probably the biggest challenge for you guys that you see in your future, and how are you guys going to step up to that challenge?
Fundraising. And fundraising is a function of our market prediction. A year ago, if we started with 0, right, and then we raised $1 million and so on. If we had started day one and let's say we had 10 million, I didn't have enough of a team, of an idea of the roadmap, of the how to do it, that we would have known how to do it. A year forward, yeah, we know exactly how we need to go about building this engine, and now it's a function of cash, and the same will apply to the launch vehicle. So it's at the end it will be cash, and we have a timeline that I think is reasonable. So we neither are trying to accomplish something that no one has ever done by doing it in 2 years.
If someone wants to learn more about Launcher, how can they do that?
Yeah, well, we have an amazing website with no information at launcherspace.com. But it has 3 links that are really important: the Twitter, the Instagram, and the email. So if anyone is interested in positions, they can just send us an email, and we post as much as we can on Twitter and Instagram. So that's kind of the blog of what we're doing. It's pretty clear.
Yeah, it's really cool because you're giving people really like a good insight into what goes into starting up a launch company.
Yeah, we're not afraid. We had The Verge coming over and for a test fire very early on, and we actually had an anomaly and we had an explosion, and it was great because we're willing to show the development process. We're not pretending we're going to orbit next year, and every rocket development company has an anomaly, and so yeah, we're more than open. We haven't posted that video yet, but we will. So
excellent. So Max, we have sort of a series of closing questions that we ask all of our guests that come on the show. No right or wrong answers. Just however you feel, whatever answer comes to mind, we'll take it. So the first of those 4 is, which rocket of these 3 do you think is going to fly first? Do you think NASA's Space Launch System will fly first? Do you think SpaceX's Big Falcon rocket will fly first? Or will Blue Origin's New Armstrong fly first?
I mean, I'm rooting for Blue Origin and SpaceX. I think it will be BFR. But, you know, Blue Origin, after more than 10 years of not achieving any orbital flight, I think more because of the detour they took. I think they have an amazing team and capabilities. So to some extent, I hope it's Blue Origin, because that will get, you know, a second SpaceX competitor to be orbital, and it's been a long time in the making. And but probably I would bet on BFR. But there's not a lot of information of how far along they are. So, but you know, one can trust that hopefully they're closer than we think.
Also, our second question: human or robot exploration of the cosmos?
Human, and I'm always torn between the idea. You know, when people left Europe to explore America, I think 90% would die on every voyage. And so there's this concept, you guys speak about it sometime, but, yeah, it should be human, and maybe we should take a little bit more risk. I don't know, but, that's what I hope it should be.
And our third question, where should we go next?
Mars, for sure.
Mars? Any particular reason why Mars over other places?
I mean, why we'll have color picture of the moon instead of black and white, like what's we are explorers, the human race. I can't get excited over the moon. I'm sure I'll be excited that day, and let's have Mars. Let's have Mars be what we fund, and if we have to make a little pit stop on the moon, that's fine. But to fool ourselves and fully fund the moon and really no budget for Mars, I can't get excited about that.
And our final question, and my personal favorite question to ask anyone, period, is why space?
Why space? I think it's the most important, gift to future generation. I think the space exploration might be the only reason our race survive over a 10,000-year timeline, and being able to contribute any, however little this contribution will be, whether actually you contribute in media, which you guys do amazingly, and historically media has always fed the exploration cycle, or we contribute in failing or in succeeding. I just wanted to, use the rest of my career to make that contribution. We'll see what it is, but any little contribution to make it more popular, to advance the technology for eventual exploration is I think, very important.
All right. Well, thank you, Max Hout from Launcher, coming on today. Thank you so much for stopping by tomorrow, and we're really looking forward to what you're going to do in the future.
Yeah, thanks, Jared. Great to meet you, and thanks for having me. So.
Excellent. All right. So after this break, we will come back, and we will have your comments from last week's show. So stay tuned. There's more tomorrow in just a little bit.
Science. It both draws us together and tears us apart, brings discoveries to cure us and threaten us. It is neither good nor evil. It is what we decide to make of it. There is so much more to learn, and we are curious. Together, let's explore the science of tomorrow.
Who's opening the segment?
Why don't you take it?
All right. Yay.
That was so awesome. Such a good interview.
Yeah, that was great.
Brooklyn.
Yeah, that was good.
Makes me so excited. I gotta go visit.
Brooklyn represent.
Word.
You're having Carrie Ann open, but you have a mic?
No. Should Jared open? Because he's got the camera.
Yeah, that's a better idea. Jared, you okay to open?
Yeah, I'm good to open.
Donna, can I have a mic on the screen?
Hearing some sort of weird background noise. I'm not sure where that's coming from.
Yeah, I hear it too. It's like a humming.
From where?
It's done.
From Max. Max's mic.
Yeah.
There's a mic open.
Okay.
That was my feedback too. As I had his mic open and my voice goes to air, so he was picking it up.
Spitfire. Yep.
Mm-hmm.
Everybody good?
Mm-hmm.
Yep.
I think so.
And we're back. Now, before we head into the comments, of course, we have to give a... I'm sorry. I'm good. All right. Let's do...
For clumps.
Let's redo that since my throat decided to stop working. And we're back. Now, before we head...
Sorry, one more time.
Okay, sounds good. And we're back. Now, before we head into your comments from last week's show, we first want to give a huge shout out, of course, to our citizens of tomorrow, our Escape Velocity citizens. They contribute $10 per episode or more on Patreon, or $30 or more per month on Maker Support. In addition, we have our Orbital citizens who do $5 per episode or more on Patreon, or $15 per more on Maker Support. And we can't forget these folks right here, our suborbital citizens as well. And boy, this is getting long, and I like the fact that there's so many names getting on here now. They contribute $2.50 an episode on Patreon, or $5 a month on Maker Support. And of course, you can head on over to patreon.com/TMRO or makersupport.com/TMRO in order to see what kind of goodies you get at the certain levels that we have for you on Patreon or Maker Support. So thank you so much for you guys helping us out to make these shows. I mean, really, when we say these shows are not possible without the help and support of our viewers, we're not joking around about that. You guys really do make this absolutely possible, and I love every single one of you who do. So thank you guys so much. It's great that we can do this. So we got some comments to talk about. Y'all want to do some comments?
Absolutely.
Yes.
You good?
Yeah.
All right.
Yeah, I realized I didn't actually.
What was last week about?
So last week, right. Thank you. I appreciate that, Mike. Last week, Jared also had an amazing interview with one Alan Stern, exploring Pluto with New Horizons, Orbit 11.08. And I realized that I didn't actually read any of these comments before getting to air, so this is going to be fun. Yay! So much fun. Because I did not pick them this week. In any case, the first comment comes off of YouTube from Jamie Godman. It says, Alan Stern is freaking awesome. I love his enthusiasm for both robotic and human space exploration. The New Horizons mission was by far the most exciting done by NASA since MSL, or MSL.
Mars Science Laboratory.
Thank you.
Curiosity.
Landed on Mars. Looking forward to New Year's so we can live it all over again. Stern is right. We really do live in the most exciting times for space exploration.
Mm-hmm. Mic drop.
Yeah, for sure. It's funny, though, because I feel like there's, whenever I tell anybody about Tomorrow Space, for instance, I always say, we have it's Tomorrow Space, it's about space, with an emphasis on human space flight. And every once in a great while, I get sort of like a nasty sort of look of like, oh, human space flight.
What?
Only humans, huh? Not robots? No, we're not going to talk about that at all.
No,
I'm like,
love for the robots.
No. I mean, like, we talk about other things. Like, it's fine. We do.
So offensive. Are they a robot? Maybe
we
they're a robot.
But like, but I think it's funny how like there's a sort of exploration space as opposed to like more just only planetary space. But we always want to go to the planets and explore that way. But then there's like this weird division between humans and robots and.
There's always exploration of space happening.
Yeah.
Regardless of whether you're like actually going to somewhere, like a destination to explore space, or you're doing like we currently have at the International Space Station, which is that you're sort of more exploring the human aspect of how humans contend with space. And some of the other things too, like additive manufacturing in space and things that are happening on the space station right now. So, there's always exploration happening, and it doesn't necessarily have to happen at the place either. I mean, we do pretty good with ground-based telescopes here on Earth as well, and our space telescopes as well. So there is always exploration happening, irregardless of whether it's people or robots going out and doing it, and that's exciting.
And plus, most of it's like a collaboration between the robots and the people anyway.
Absolutely.
So it's just like,
yeah, the robots cannot operate without the people telling them what to do.
Word.
And likewise, we're going to need help from robots when we go out as people as well. I mean, even on the space station, you know, there's a robotic arm on there for it. So I mean, it's just everything kind of works together. And it works when both work together at the same time.
That Canadarm is so difficult. I did a VR once trying to like actually dock it, and it was so bad. But yeah, one of like you being at the ISS is pretty cool. Talk about collaboration of robots and humans.
Yeah, I want to say, if you're ever interested in a visualization of trigonometry, the Canadarm is a great thing for that. So.
All right. Next comment. Right, mic drop on that. Next comment comes off of YouTube from Sean Hutchins. Says, could New Horizons reach Planet 9 and X, or 10, with its current trajectory, assuming they really are out there? Because it would be amazing to have a probe on the way to a planet before we even knew it existed.
Well, to kind of piggyback a little bit on that, the target that New Horizons is going to be flying by on New Year's Eve, New Year's Day, depending on where you are on the Earth, which is 2014 MU69, which hopefully will get a nicer name soon.
We name them after we see them. It's kind of like sometimes you can't name a child until you see it.
Until you see it.
Exactly.
Like, I wanted to call him Abraham, but you know, eventually was like, no, you're a Johnny. Sorry, that's just the way that goes.
I'm gonna call you 2018 VX47.
Hey,
so
you never know. Go on.
2014 MU69 was not discovered before New Horizons was outbound. It was discovered in, you guessed it, 2014.
Oh.
So, and they actually,
I love the simplicity.
They did a survey to try to find Kuiper Belt objects in that region, and they didn't find any with ground-based telescopes. It literally took Hubble in order for them to find those. They found two, by the way, that were along the trajectory. It's just that 2014 MU69 used less fuel to get to it, which means they could do it, which means that they could burn, but then they'll have more fuel for a more precise flyby of it, and that's why specifically 2014 MU69 was chosen. But as in regards to Planet 9, I think Alan Stern would make a very strong argument that New Horizons already did fly by Planet 9. It was called Pluto, and I am inclined to agree with him too. And as far as anything else beyond that these days, they're still looking for the hypothetical Planet 9. So
go ahead, Mike. What's up?
Go ahead, Mike.
Exactly. We don't know whether or not this additional planet, whatever size it might be, does even exist. But you know, the whole gravitational disturbances and whatnot, you know, is the reason why we think it was out there. And looking for whatever object that might be is how we discovered Pluto in the first place, and lots of these other objects. And Mike Brown, a leading astronomer who was one of the discoverers of several of these other dwarf planets like Eris and Makemake and Haumea, has been collaborating with, I forget what his name is, you might know, Jared. He's a Russian astronomer.
Yes, Konstantin Batkian. Yeah, Konstantin Batkian. He's a heck of a guitar player too. So.
Yeah, even if you go and look at their paper and see where their estimations of where this object might be isn't in the same trajectory as New Horizons anyway. So let's assume for a minute that this planet even does exist. New Horizons probably would only be able to take, like, you know, some long distance pictures, like with the calibration pictures that we saw, you know, when it was first taking photos of Pluto.
Yeah,
so,
actually, if you're
not even close to it.
If you're interested in where this hypothetical planet may actually be at in our solar system, it's out of the ecliptic, or the plane of the solar system. It's actually very close to the constellation Orion. So if you could look up and see Orion at night, maybe take some pictures and you can help us find it. I don't know. Yeah. It's very difficult. They've been doing this for, I guess, 2 years now, and they've still got nothing. But that's the thing about specifically astronomy, is that you have to have to wait for the sun to get out of the way in order for you to actually look at it. And you only get a couple months per year of good observation of a specific area in the sky because of the glare from the sun. So it's both like, I haven't found anything yet, but it's also like, well, you know, that's the actual process of how astronomy works. Is that it really is, these studies do take multiple years, not necessarily because, you know, we're clueless for years, but because our observation periods are just actually really tiny. Because the sun, I really like the sun, I appreciate it, but dang it, it makes astronomy hard.
It does. So. And all of us nocturnal.
Yeah. I mean, I always tell kids that if you really like staying up at night, become an astronomer, because then you'll get paid for it, and you can rub that in the face of your parents when you get older. So.
Yeah. Word to that.
That's hilarious. All right, the next comment comes off of YouTube from one Thomas M. It says, awesome interview. People like Dr. Ellen Stern are making the Star Trek future we've all been waiting for a reality. Missions like New Horizon is what will help young people go into the STEM fields, which is science, technology, engineering, and math. I'm going to throw A in there with art. With more young people going into science and technology, there will be even more awesome futuristic technologies with space missions. We are living in a renaissance of space and technology, and it is an awesome time to be alive.
I love that comment.
Agreed.
That is great.
Yeah.
Yeah, I definitely agree.
I was like, yep.
Yeah.
Okay, well.
You can tell I didn't pick these because I was like, let's go for something controversial. This was like, yeah, no, we all agree with that. Go ahead, Athena. I don't mean to cut you off.
I mean, it's literally like, you know, it really defends what a lot of us, what we're actually here for, and this is why we're doing it. That's why we care so much about this stuff. And I like that you added in that extra A for STEAM, just because, like, that is a huge impact in just... Yeah, like he's even said, like trying to get the newest generations up and running and getting into this stuff. And it comes from missions like these that really starts to push the youth into saying, oh, I want to do something with this. And I also love that there's so many schools that talk about this too, and they actually will cover a lot of these missions. And I think that that's so great. I actually, after last week's show, I saw on Twitter a whole bunch of comments back towards when we were talking about trying to find schools that do more outreach. And there's so many more programs that actually exist now, which is pretty exciting, where they will team up with schools for missions like this to actually like observe maybe like a launch of it, or actually observe some like collected data. I mean, one of my favorite things actually is like NASA Eyes software that you can download on your computer, and you can literally track like any of the missions that are currently, any of the satellites or the rovers, and you can watch like live data. It's all like CGI and it's graphics.
Sure.
But it's so cool, and it makes it really, really fun. And if you just play like Mozart in the background and you play with it, it makes for a really nice afternoon. And there's a lot of these programs for kids, which I think is amazing. So I definitely, like I said, agree with this comment. But I think that's great because we are doing that with missions. We're teaming it up with students and STEM programs, STEAM programs. So, yeah.
Totally. And honestly, if it wasn't for the A in STEAM, we wouldn't get super awesome shirts like Mike's got on.
Yeah.
Yeah.
Because, I mean, let's be
seriously.
I mean,
it's amazing.
It's me outer space. So,
me outer space.
Have you guys seen the artwork that's on the Dove CubeSats that they add on every single one of those?
No.
I didn't even know they did that.
Tribal tattoo inspired art.
Yeah.
That's Planet, formerly Planet Labs, right? That does the Dove spacecraft.
Yeah, I think so. Yeah.
I get them mixed up time with the other time.
I know, right?
Cool.
Anyway, yeah. They have artwork that's printed on the underneath like the solar panels on every single one of their Dove CubeSats. Yeah, and it's really cool. You should just go through maybe an After Dark or something. And
Oh, that looks cool.
Yeah, I think we all know what our next tattoo is going to be.
Yes.
I love like there's one of like
CubeSat.
it's like a cyborg dove. That's pretty dope. It's a dove and it has like it's like half robot. It's so cool. I don't know. Yeah. These are great. These are amazing.
They get it. They get it. Theme artwork too.
I love it. I love it. Oh my goodness. All right. Last comment we've got up is from Jared Leggett off of YouTube. Says I used to do public outreach talks for K-12 schools in West Virginia, I'm assuming is WV, between 2013 and 2015. It was not a rare thing for students and some of the teachers to think that NASA had been closed down and not know about the NASA Independent Verification and Validation Program in Fairmont, West Virginia. The people who lived in those counties or adjacent counties would know or were more likely to know, but the next county over that they may have not even heard of the facility. Whew, like I said, did not read these before going on air. There's clearly an outreach issue, particularly in rural areas. Yeah, I think that's just sort of across the board, which is funny because here in America, NASA TV and access to information that NASA has is super easy. It's pretty well known, I think. It's what helped Space Vidcast kind of get on the map to a certain extent. We just got a really big satellite and put it outside and pointed it at the bird and got NASA TV. Like, really easy to do, other than like trying to source that forsaken satellite. But other than that, and having somewhere to put it, again, thank you, CAF. I think it's always interesting to me. I think as long as you have some sort of interest, you should be able to find it. And again, this is only speaking for the U.S. It's really easy in the U.S. and it does always surprise me when anybody is like, "What? No, I mean they stopped running the shuttle, so therefore the entire NASA program is shut down." Like, I don't even know why they're getting money. Like, what are they doing anymore? And you kind of sit there and go, "Are you Falcon serious right now? Like, I don't even understand. What is happening?" Oh my gosh. I know, Mike, you've run into some things like that as well.
Yeah, but I like, though, that now that at least even after the shuttle program has retired, yeah, you hear that comment all the time, but at least people have, like, heard of, like, the Curiosity rover and New Horizons, like, oh, we got those awesome pictures from Pluto, so I guess NASA is doing stuff.
Yes.
And there's a lot of times where that'll start conversations. Like, I thought NASA was over, but yet we're doing stuff on Mars, and we took those pictures of Pluto. Like, what else are we doing? And, if they'll listen, that just opens up the whole can of worms of just like, oh, NASA's doing this and doing this and doing this, and we're collaborating with all of our international partners to develop new engine technologies and new different ways of surviving in space and pushing the boundaries and all of it.
Yeah.
Yeah, so I like that a lot of these things are starting to be a little bit more publicized, and of course with like Falcon Heavy and that's getting more and more. But what this comment is more addressing is on the local level, those type of outreach things are really, really hard to find. It's out there, and if you look, then you can find it, but I don't know, and I don't know exactly what the solution is for it either.
I feel like a really good solution for that is for us to just kind of start talking about it in casual conversation.
Yeah.
Because I mean, I talk about space on Twitter and Facebook a lot, so people tend to come to me for just a little bit and ask questions and things like that. But there's other ways that you can do it too. You can become like an official person. Like I just joined the Jet Propulsion Laboratory Solar System Ambassador Program.
Congratulations, by the way.
Thanks. But that's something that you can actually join, and you can go out on behalf of these groups and actually go talk about that to people who want to do that. But there's other ways to do that too. Like if you want to get in astronomy, the Sidewalk astronomers who are based out of San Francisco, they have a tremendous network throughout the United States where you can actually, if you got a telescope, you can contact them and they will send you places to go with your telescope to allow the general public to just kind of look through it. So, there's lots of ways that even if you're not a space geek or in the industry, you can actually contribute to helping get the word out about what's happening right now. Because one of the things that I do hear a lot of up at Griffith, like in my top 5 questions that I get from people besides like, if we throw where are the bathrooms at, out, one of them is, oh, NASA's still a thing? Right. I thought they were closed down, so that's not necessarily something that's just a particular rural area kind of misunderstanding. Even here in Los Angeles, what you would expect, people who are in the know and everything.
Max was like, yeah, we didn't want to be in Long Beach because we'd be competing with everybody.
Yes. Even here, even here, which may be discouraging for a small sat company to join because of the level of experience in the area. Even here, there's people that don't know.
In New York, I used to get that a lot when I was working at the Space Shuttle Enterprise, and that was at the Intrepid. So many people really thought that NASA wasn't happening anymore. And for me, what I feel like what the solution is trying to intermix with every single type of person you possibly can, because there is a big it's like the world really does work a lot like high school, where everyone kind of stays in their own groups.
Yes.
And there are intermixing, which is great. And it happens a lot, especially in big cities like LA and New York. But for me, anywhere I am, I talk about space. If I'm in an Uber, I talk about space. If I'm like in a bar, I talk about space. Like, it just happens. Like, it literally does. And like with most random people that aren't even in the industry and have no idea about this stuff. And so I made it a mission before I even thought I would be living here today. About a year ago when I was in New York, I was like, I'm going to try and find every single thing that happens in New York that's somehow space or science related. I can go to that's literally free and just fun like AF, like literally just go and do stuff. And it's all sciencey, but it's cool and it's fun. I mean, there's so many different things that I've literally made Facebook groups and just like added all my random friends that know nothing about space. If they're like, and I have like an abundance of friends in so many different communities, and they're just like, yeah, you know what, like I'll go with you and do this. Like, and then they have no idea about, like you were saying, these missions going to Mars. And I think that that's something that it's not just the coolness factor, but the bigger picture factor of tying us all together and how we're all intermixed as a species. And I think, just the main thing is trying to get to everybody else who's not just also like the only way, like you were saying, for people to know about this is they go to the Griffith Observatory and then they hear you talk about it. But if they decide that day, I'm not going to go to Griffith Observatory, or they maybe don't know even about Griffith Observatory, which would be weird, they would end up going maybe to like some other park. They'll have no idea unless there's like, I don't know, someone who happens to be sitting there and talking about space shuttles, which would likely be one of us, you know, or rockets or something. Yeah. So I think it's just that the vocabulary hasn't been adapted as much in social environments than everything else, like Instagram and, you know, who's on this reality show or something, you know. But we should have a reality show about rockets and like us. Okay, no, anyway, okay, I'm done.
I feel like we do.
Well, we do. This is true. Wait, we do. Right.
At least a peak. This is at least a peak.
We're on a show right now.
That'd be so cool, though. Like, actually, a challenge of all these different startups and stuff like that. That'd be so cool to be following, like, all the startups that we've interviewed, like, within the past year, to follow all their progress and have, like, weekly updates. That would be amazing.
Yeah, it would be amazing.
Yeah, I feel like there's a certain level that for a lot of people, space just seems completely intangible. It's not something that I can ever experience because it's simply for people who know significantly more than I do. And having worked in the industry, I can say that's not true.
That's totally not true.
But you know, it's just one of those things where I feel like once you show people stuff, they definitely do get hooked on it. It is, I guess, how would I describe it? Communicable excitement. It's possible, and we should spread it everywhere we can.
Yes.
Totally agreed.
Anyways.
We're all doing a dramatic stare at the camera.
Just the weird stuff that goes inside my head. For anyone who's seen the IT crowd, look up friend face. In any case, I think that's the end of this segment. But before we go, I want to make sure I give a shout out to those of the ground support citizens. These people have contributed $1 or more per episode on Patreon, or $1 per month or more on makersupport.com. They, of course, also get their name in the show because that is the very least that we can do, and give them a shout out towards that. They get access to our exclusive citizen-only hangouts and early access to After Dark, which is about what we're going to do next. If you, again, are interested in becoming a citizen, please join us. We do this all the time, and we would love to have you with us. Head on over to patreon.com/TMRO or makersupport.com/TMRO. Again, your choice. Now, next week, I'm very excited to have back on again one of the hardest names that I have learned to pronounce. This is Dwight Stephen Boniecki, searching for Skylab. It's a Kickstarter campaign, as we always like to have. And see, there it is. Oh,
wow.
So
what a beautiful vehicle.
So cool. Anyway, so Dwight's going to be with us next week, so that'll be very exciting. And we just like to say thank you to all of you for joining us this week. If you are watching live, After Dark is up next. And if not, I guess we'll just see you then. Bye.
Oops.
Clappy clap. That's funny.
Tars, you said you found Specific Gas due to Chris Pirillo? Like, you need to explain that one to me.
I feel bad. I broke my my pantomiming there. I was looking off this way.
Oh, you said pantomiming. That is not what I heard.
That's not what I heard either.
Whoa. I know it's
whoa.
after dark,
Pants.
buddy, but man, hang on.
Something new every week.
Space cats without pants.
Yes, space cats, no pants.
I'm not wearing pants right now. Film at 11.
Okay, seriously.
What's up?
I don't know anymore. Right, I heard pants too. It was very confusing. Very
Pantomime. Pantomime.
I broke my pants.
I love that episode of
That's what I think of when
SpongeBob.
I'm like staring off towards you guys. But yeah, while Athena was speaking, I was like staring off this way. I'm just like, oh wait a minute, you're supposed to be
Like, I don't care what she's saying. We're just going to ignore her.
I'm
She's not even here right now.
Like, nodding my head, just like, oh yeah.
Oh, that's so funny.
Mike, I love it. Also, it's so much fun that, like, you know, again, you're not in studio with us, and I think a lot of people forget. I think we even forget.
I forget too.
I'm like, he's right there.
I didn't even notice until you said it, and then all of a sudden you're like, wait, hold on, over on this way. Like, dude, you
Oh, geez.
you work your magic. It's ridiculously impressive. I cannot laud you enough for that. It's
hilarious.
So good.
Thanks.
So good.
Oh man. That's so funny.
Do we know how we're doing? Are we doing the pods and then science? Hello, Miss Jade.
Hi.
Hi, Jade.
We have 15 minutes before science, right?
I think so.
We're doing science at noon. Is that correct? So does Mike? I didn't look. Who has a pod today?
I also have a pod.
Let's do Mike's space pod.
Right.
And then if we need time, we can hold Athena's space pod until after science.
Right. Okay.
Let's do Mike's, and then you can get him off.
All right, Mr. Mike, it's all you. Unless you have something else that you want to say before.
Mike, give me just a second. I'm talking Lisa through running space pods.
Oh God, we're gonna let Lisa press buttons. That's a terrible idea. She didn't hear me, did she? Yeah, she did. You know I'm kidding. Although that board is like as big as she is. Sincerely.
It's so big.
Oh man. See, yeah, we're gonna do a space pod talking about something that normally Jared would have talked about, and yeah, it's gonna be good. Hayabusa 2 and Ryugu. When this thing actually happens, I'm sure that Jared's going to be very excitedly talking about it, and that's going to be great. I love all the robotic spacecraft stuff too, though. Like, don't you guys think that I'm just like a human spaceflight only? Like, I agree with what we were talking about earlier about the human and robotic collaboration, and I like a lot of the robotic probes and especially the interplanetary missions. And Akatsuki was probably one of my other favorites, and the kind of salvaging its mission to get into orbit around Venus. So this one's going to be cool too. Hayabusa 2.
That lets you talk
Just
to Mike
waiting
until you
from-
tell him that you're ready.
Hey, Mike, I think I'm ready.
All right, hello Lisa. All right, let's. I guess we'll give this a try then. And okay. Hello, everyone. Today I wanted to talk about a topic that normally our resident astronomer, Jared Head, would be talking about, and that's Hayabusa 2 and its mission to rendezvous with a near-Earth asteroid this summer. Well, Hayabusa 2 has taken its first image of that asteroid, and that's what I wanted to talk about today. This is your space pod for Tuesday, March 6th, 2018. Hayabusa 2 was launched on December 3rd, 2014 aboard an H-2A rocket, and it's a follow-up to Japan's first Hayabusa spacecraft, which rendezvoused with a near-Earth object, Itokawa, in 2005. You know what, let me start over. I'm tripping already. It's cool. Hayabusa 2 was launched on December 3rd, 2014 aboard an H-2A rocket, and it's a follow-up to Japan's first Hayabusa spacecraft, which rendezvoused with a near-Earth asteroid called Itokawa in 2005 and returned samples of that asteroid to Earth in 2010. And it was the first spacecraft to ever do so, to return samples from a near-Earth asteroid to Earth, although the sample size was much, much less than expected, only a couple of grains of dust. However, Hayabusa 2 aims to address all the different weak points that were identified in that mission and return a bigger sample back to Earth. The probe still has over 1 million kilometers to cover in order to reach its target in June for a 1.5-year exploration mission that will see the spacecraft dispatch a series of landers and an impactor while also making contact with Ryugu itself to scoop up sample material and return that sample to Earth in December of 2020. And the first optical images of Ryugu, only appearing as a small speck of light, have been taken by the spacecraft on February 26th, just this past week. And Ryugu is a 920 meter C-type. Let me start over from the optical images right there. We can just leave it on these images, sorry. The first optical images of Ryugu, only appearing as a really small speck of light there, have been taken by the Hayabusa 2 spacecraft on February 26th, just this past week. And Ryugu is a 920 meter C-type primitive body that is hoped to hold a treasure trove of scientific information that hopefully will have all the different preserved record of the early days of the formation of the solar system. And with that sample, we'll hopefully be able to advance that science even further. Now, the asteroid was officially named Ryugu on October 5th of 2015, and its name refers to a Japanese folktale called Ryugu-jo, which means Dragon's Palace. And the Dragon's Palace was a wonderful and magical palace at the bottom of the ocean where the hero of the story, Urashima Taru, was brought by a turtle. And when he returned from that palace, he brought back with him a mysterious box, which, just like Hayabusa 2, will bring back a capsule with samples to Earth. Now, Hayabusa 2 was designed with ion engines to perform multiple long burns and adjust its course in its heliocentric orbit and get a gravity assist from an Earth flyby and adjust its course as needed for the eventual rendezvous with the Ryugu in early June this year. Now, aside from the primary sample collection and return system that the spacecraft will have, it's also going to dispatching 4 landers. The 10-kilogram Mascot lander built in Europe for an in-situ study of surface composition and properties, and 3 Minerva landers that are similar to a Minerva lander that was on the first Hayabusa spacecraft, which are going to deliver imagery and also have temperature measurements of the asteroid. And all the landers are going to make several hops across the asteroid's surface to take those different measurements at different locations. And another payload is going to be an impactor that's going to be deployed towards the asteroid and use high explosives to generate a really high-speed impact that's hoped to expose enough material so that it would be easier to collect a sample with Hayabusa 2 later. And there's going to be a deployable camera that hopefully will be used to document that impact of the penetrator. And here's just one other really cool time-lapse image that was taken by Hayabusa 2 on December 3rd of 2015 during its Earth flyby maneuver. And if everything goes according to plan, the return capsule should land in Australia. So hopefully everything goes well with this, and we're going to see just in a couple of months what this asteroid is going to reveal. But don't forget, if you haven't already, to check out our last week's show, which we had Max Hope talking about launcher systems, and it's going to be a really interesting interview that we had for that. So definitely check it out, and be sure to check out every live show that we have every Saturday at 1800 Coordinated Universal Time. Like, subscribe, and share these videos with your friends, and if you can, support us on patreon.com or makersupport.com. But until the next time I see you guys, keep moving onwards and upwards, and don't forget, Ad Astra to the stars.
Good job, Mike. I think that was fine.
Thank you. Tripped up quite a bit, but we're short on time, so we'll just have to move along. You did great, Lisa, by the way. Your button pushing was on point.
Mike, that was perfect. You got everything spot on it.
Yeah,
great job.
We're going to do Athena's after.
Oh, thank you. Oh, you mean about like all the info and stuff like that?
You got all the science right on it. Awesome, dude.
Thank you very much.
Awesome.
Thank you.
Yay.
And yeah, I'm super
hopefully,
excited about that mission. I was like spazzing out when you were talking about some of the things. So
You
for real,
did.
but hopefully we do get a really big sample back this time.
Oh goodness.
Remember the reveal when they opened up the capsule last time and there's just like barely nothing?
yeah, it's just little grains, but it was still important grains. So
yeah.
I love it.
Confirmed that it was indeed from the asteroid. So no, it was, yeah, this.
And like Randy says,
it's
no
gonna
long
be-
guy this week, so that's looking up all the way around.
yeah.
Yeah, definitely.
All right, I am.
I love how
Sorry I
everyone
freaked
had
out so
to.
much last time. It's just I remember having like a conversation with him, just being like, "Oh, hey, I'm doing this thing," and he thought it was really cool, and so he agreed that he would come by like around like 3 o'clock or something like that.
Right.
And shows up at whatever time it was, like 12:30, 12:45. And sorry for getting so upset about that.
Oh, too funny. Yeah, so we're gonna end up doing your space
At the
pod.
end, right?
Yeah,
Yeah.
is that
Okay, that's what I figured, yeah.
we figured. We just want to make
That's why
sure
I
that we
changed
get
now because of
Yup.
the next segment.
It's funny. So Athena and Jared were on for space, and they're also going to be on for science. Say hello, Lisa. But they both wanted to change. Which are you changing?
And
or
I
not?
forgot.
What's going on?
Wardrobe
You.
Yes, I like your other shirt too. Put it on.
I don't think I fit in it very well.
Oh no. Well, you could just put it on over that too.
Yeah,
if
let's
you
say
want.
put it over this one.
Mr. Mike,
Keep it
I'm
on
sorry.
mine.
You said something, and I talked over you.
Nope, you're fine.
Okay.
You're fine. Anyway, I should probably sign off then. Did you guys say that you were going to do Athena's pod now, or?
No, we're going to do Athena's
gonna
pod
do it at the end.
after.
Yeah.
She's got a science and a space pod to do, and we're just going to do them later because we didn't want to run into delaying science if we can help it.
Yeah.
So many cameras.
Also, what's really funny is that all three girls are wearing black today.
I know. I just realized that too.
It's my Buckboard shirt, right? And then
I love this.
I should have
Mine
worn
is
the
just
other one.
plain,
The
but-
other one has like the still testing patch on the front, and then on the back it says like launch team. I should have worn that one. Regret.
Well, you have it for the next one, the next show. Options. What's it called? Okay, so now what do we do?
You need to go and do science news.
Oh, yeah, okay,
I'm not-
bye.
you two and Jared are doing science news.
Okay.
You guys need microphones.
Yeah.
All right. Well, good luck, everybody, and I know you guys are going to do great. So,
Yeah. Thank
good
you,
luck
Mike.
with
I
this.
appreciate it.
Thanks, Mike.
See you guys next week.
Yay.
Yay.
Bye.
Bye. We have all of the things.
Oh, my lips are chapped again. Damn it, Winter.
No, I 5 minutes out.
With her, where I'm just like,
Can I have your ears?
Yeah. Because I don't need them. Of course.
Yes, I need a microphone.
Oh, vey. Oh,
Max's. He's still wearing it, right?
he is. Although, let's ask Dada which one he wants on you. Because he might actually want me on you or somebody else.
Probably Jade. One of you goes to Jade because she's doing the news, right?
I want to be on this screen.
Right. That totally makes sense.
Like,
yeah. So then you need Ben's mic, which I think Athena has.
Go to New York for a modeling gig or something.
oh yeah, that would be fun. I've been
No,
wanting to go
you're
back
Ben,
anyway
though.
for something. Well, while I'm there, I
You're
should
not
visit
guest. Right. So
Brooklyn for a little bit. That'd be fun.
I know. How are you
Do you need
guys?
help with anything?
Changing
Or
then
okay.
That'll mess up news.
It is worth changing if it helps Dada.
What if I grab Max's mic now and then me and Athena just switch packs?
You gotta talk to Dada. Don't talk to me.
Which microphone should I use?
Sorry, guys. I know this is really weird. We have all of the microphones are all over the places. I'm pretty sure you're wearing Ben's, right?
I don't actually know anymore. Jared, I think.
Oh yeah, no, you're wearing Jared.
Okay. Should I give Jared?
That is a good question. No, I think you're okay. You're
good,
probably
I hope
okay
so.
on Jared. It's all going to come down to what Dada wants. Because typically, Jared and Carrie Ann, I don't have ears, so you're going to have to relay something. Sorry. No, I got nothing.
You were saying
You can
words.
talk to me all you like. I can't hear you. I can only talk to you.
I can repeat it.
Gotcha.
Oh. This is so much fun.
It's such a fun month. Yes, it is.
Yeah.
I feel like a cyborg, all these like wires everywhere.
Oh, I think I only have 6 minutes and 37 seconds left. Oh, is that 6 hours and 37 minutes? That's so
the
weird. I've
battery
never heard
today?
that before. Guest has guest right now. Do you want guest to have guest, or you want? I'm not the star woman. No, negative.
Totally professionals. We do this every month.
And to be fair, I mean, this is a weird one.
We just have too many people and not enough like things, right?
What if we just start talking into each other's
If
microphones?
we just got more microphones and more ears, this wouldn't be a problem, Benjamin. And I can say that because I know he's not listening.
How's it going?
So there's that.
I know. That's like, and then yeah, I like it. We all kind of have like a uniform going on. I think last time it was like that with us too. Were we all wearing black, or was it gray?
Except for Mike. Yeah,
Except Mike.
was like,
Yeah, he was wearing blue.
Yeah. So who do you want where?
Here, I don't.
No. Microphone wise.
Oh, that's
That's good?
Yeah.
All right. So everyone has whatever it is that they need or want. Cool.
I want to get like a big microphone.
Be on yours.
Sure.
What mic do you
Y'all
have?
ready to do some science?
Do you have a
Yes.
mic right now?
No, I do not have my
Right
mic.
over there.
Oh, so you want?
Yeah.
Oh shit, I was like, did things change?
I just figured since like
Okay.
You can have mine.
since the camera
But
was
then
still
that
going
means
over there, I was like, oh my.
y'all are
going
going to be in silence for a little bit. We're going to wait for Jared to get his ear in because that's always a lovely thing to listen to.
Duper, duper,
I should do that right we start.
Guys,
Guys, I hit a growth spurt.
You're fine. I'm talking to them.
becoming more supermodel-y as the days progress.
That would be like beyond the level. It would be like you're too tall. You can't actually model anymore.
I know, right?
Like Carly Kloss is like the maximum height.
She's like 6.
I think she's 6'2" or 6. No,
If you did something wrong, you'd hear my mom voice.
I'm pretty sure she's 6'1".
And I promise you would actually hear it.
Oh, I need it.
No problem.
It's amazing. Are you gonna have to go up all the way through like everything?
Yep.
Or just
That's
like
what
around?
we like to hear.
Okay.
That is 6 hours and 35 minutes. I've
Maybe if
determined,
you
so
want
that's
like
good.
hang it
That'll
here
be
and
plenty
then
of
just
time.
hang, like droop it over the
Apparently,
back.
after a while, the batteries tell you how much time you have on them.
This is the first time I
Right?
actually tucked
That's
it
what I
into
thought.
the clothing.
Hi.
That's cool.
It was such a
It's not
projected
gonna help
high.
when somebody's listening to you. Okay.
All right.
Yeah,
That's true.
I do now.
What if I
You need this mic, and then you're going to go be me. Okay?
Going in there? What am I doing?
It's news! What did you think was happening?
I just saw everyone gathered in here, and I was like, wow, look, everybody's in here.
Did you hear my mom voice on that one?
Yes, I did.
Good.
Sorry, Mom.
Sorry, kids, not yelling at you. Nice talking to you. So sorry. Gotta go.
Oh, they just go backwards. Oh, God. Hit the other button.
So many buttons.
Yeah, it's a bit of a pain in the ass. It really is.
Can't you just like innate them, just like drag them to one different place?
No, not through the tool I have.
The ears?
Oh, there are so
ears, yeah.
many laptops in here.
I'm not sure where they are.
Whoa, bro.
Do you get some more earboxes? She doesn't have a
I need a
one for the ears.
But I have ears, but I need like the box that disconnects.
Yes. HB1 or Lisa?
Where
I
am
didn't
I
really
at?
like that.
Oh wait,
Yo.
so we don't need this then?
You'll want me standing here? Yeah, it's the tall
Yeah,
group here.
I think it's
so-
good. Yeah,
Well,
no.
no, I'm the short. I'm the short one.
Yeah, you are the short one, Jade. I'm very sorry.
Wait, Jared, how tall are you?
I'm 6'3".
Okay, yeah.
Not 6'3",
Yes, I
Jared.
am.
Yeah.
Hold on,
Yes,
wait.
I am.
Take this off.
Take them off. Hi, Chad.
Hi, Dad. Your dad height for sure.
I think we should all wear
Dad
like
height?
heels one day.
Yeah.
How much datitude does this shirt give me?
You're like on a scale of 1
I
to
love
12 at
that.
least a 14.
Sick. So.
And I didn't. The only reason I didn't say 15 is because you're not technically a dad yet. But if
Well,
you
I don't
were,
ever really want to be a dad, honestly.
I mean, you could be a dad in the figurative sense.
He's like my children's, though. Does that count?
Just in
So you're like a grandpa?
I guess.
Hey, are you my dad?
Maybe.
Swap shirts.
It's not out of the realm of possibility. I am adopted,
Honestly.
so.
You're like you produce, science, and joy for the world. So in that
Well,
way,
I don't think I got your
Joy, not
Yeah, I
joy.
don't know about joy.
Not
joy. Oh, your IFB's here.
Oh yeah.
oh,
you need these.
my ear gum.
I think it's back here.
It's no longer gum shaped.
Yeah.
It's
Well,
ear
then,
shaped.
color me. This looks
Thanks
I
to
got
Wicked.
them. Ben, I got them.
Thanks to
They
Wicked.
were back there.
Thanks.
Yeah.
Do I get to keep the box too? What?
Right?
Is this
I gave it to her. Yeah. I
Oh
wasn't
my
saying it loud
gosh.
enough. I forgot you don't have
So now
earphones.
you would expect it to be super comfortable. It's
I heard
like
it's
the
not.
opposite of that.
Yeah.
Is it right or left? I forgot.
I'm not sure which one you
Red.
Red
right.
is right.
Okay.
Do you want Jared in the middle? Is there transitions?
Oh yeah. We need Jared in the middle.
There's also a lot of like black
and
clothes
then
happening.
Am I doing
over here.
I'll break it up a bit. Can I put this
Yeah,
somewhere?
I'll put this
Okay.
in a place.
Hello, internet.
What was that? Gross.
So close.
Extreme close up.
That's so creepy. Look at you.
I just vomited. Out both ends.
It won't be
Can we please save that and just like put it on loop?
Recording.
Oh man, that was so good.
Perfect, Jade.
Can you two
Should be
switch
like-
your, don't move your computers, just move your bodies. Switch your
Okay.
I think I'm doing this wrong.
You might be.
Oh, I've never been on this side before. Can I be on this side?
I've never been in the middle before. Anyway.
The lighting is a little
all
different
right,
here. I
well,
like
Yeah,
it.
Or is it backwards?
Let me show you an example. Where
What if I just like?
Oh wait. Maybe if I just
Jade's
really get it
computer.
in there. Oh wait, I got it. It's in.
Yay!
Ooh, it's in.
It's in. It's in.
It's gonna block most of the sound out of that ear.
Yep.
Oh well, hold on. Then.
I keep mine like half in.
I like that better.
Welcome to tomorrow, IFB.
It's like being at the doctor.
It's a, you guys, it's a doctor.
So, here is a visual example. Right, it loops over your ear, and then it goes
Yeah.
in.
Yeah, it's cool though, right?
Into place, and it's gonna slide into your ear canal. So you have to twist it in, if that makes sense.
Yeah, I get it.
Never pull on the cable when you're pulling it back out. Loop your finger around it and kind of twist it back out.
Dig in there.
Yeah, just dig in there and pull it back out. It's gonna be not fun in either direction. But once it's in, it will block the sound. Yeah.
It's twisted.
We're talking about animals today, right?
Let's go ahead and make this your primary position. So if you happen to
testing, yeah.
Switch your computers for me.
Animal
And
testing.
you need a new big name banner.
Oh,
Since I have to build a new name banner,
Yeah.
now I
Here
There
you
you
go,
go.
lady.
Thank you.
Nice necklace.
Thank you.
Just a byproduct. No, it was
My
not.
friend designed it.
Jade on the other side.
Get.
Juno.
Yes.
Oh. Oh god. Oh, the internet. It's weird not being able to hear out of one ear and hearing out of the other. I feel like I'm gonna fall over.
I can't hear out of both now, but I get sound in one. So
Oh.
You haven't taken any of the vitamins, have you?
I haven't gotten them
You
yet.
haven't gotten
so.
them? Okay. Are you going to go to a doctor about them? Because you're
I
ears,
did.
right?
I'm on like almost 2 full grams of amoxicillin daily. So
Okay. How long have you been
that's
on?
the good stuff. Since Tuesday. So
Wow. Hopefully soon it stops.
yeah, it was a
Usually
full
it knocks
full
fast.
infection of both of my inner ears, and it was awesome too because like when at its worst, I was like losing my balance and everything. So that was
Oh
really
my
cool.
gosh. No.
That was awesome.
horrible.
No, it wasn't. Like I was just standing at work,
Like
and
high
then
from
all
ear
of a sudden,
infection.
like the room started rotating, and I was like, "Whoa!"
Oh my God.
I need to sit down. And then I sat down, and like, and you know, this is someone from the public came up to me and started
Yeah, that's
asking
good.
questions. So that was fun.
Jeez.
So
Is anybody not ready?
Ready. You feel this weird cord.
Ready is all under me.
she kind of like,
Oh wait, is sound like, or have you already tested sound?
I mean, Dad Dog's not wrong.
Let me identify. Let me identify. Jade, can you talk, please?
Hi. I had breakfast this morning. Comprised of a builder bar, which
Okay.
is
Nice.
okay.
Give me more, please.
Give you more? Well, it had 20 grams of protein, and then I think there was like 23 grams of carbs, which is great because that helps your body to.
Awesome, thank you.
Okay.
Need to like.
Yeah, I know, right?
Cheers.
It's just- y'all ready to get amped up here? We're gonna talk some science and things.
I know that's what was happening to me. That's why I hold it.
That's on your belt, because that's expensive.
This is why we.
Oh, okay. Neck.
All right.
Okay. High School Musical throwback.
Sweating to the Science with Jade, Athena, and Jared.
Sweating to the science?
Sweat into the science?
I guess. I don't know.
Actually,
It sounded good, and then I said it. So.
Yeah,
Are we
they should. That's
rating?
how they usually are.
Okay, I'm ready if everybody
Is
else
Lisa
is
joining us?
Okay.
during the topic.
Yes,
Yeah,
that's what I was going to ask. All right.
Yes.
Word.
All right, who's ready to do some science?
All right.
I'm it.
Let's do a science.
Yes.
Can we do a science? Uh-oh.
Hey, I can't see her at all. She's totally too dark.
Oh,
Jade,
no,
can
I'm
they not
sorry.
flip-flop?
How about now?
I was looking at their hair. Her hair gets completely lost in the background along with the rest of her body,
I believe you.
which is why I swapped them.
I'll wear lighter clothes next time. I'm sorry.
If she's totally dark, is there a way we could like angle the table a little bit more?
No. I see what you're saying now. Yeah, no, you're totally right.
I can roll my sleeves up a little more.
I'll roll my sleeves up.
No, you're gonna. No, now it's like illuminating.
Whoa.
Now we have a secondary light source.
Whoa.
Yeah, I was going to say.
I've never looked tan before. Oh my gosh.
You could bounce some light off of me. The shirt does not fit as well as.
Jared put on Jade's dress and Jade put on Jared's shirt.
All right, come on,
Okay,
take it off.
so all
Perfect.
right, here we go.
Now I'll be the dad of the group.
Yes, and I'll be.
I'll have the daditude.
Oh,
More
man.
Tisha.
Do we have to switch shoes? Because I'm not experienced wearing heels.
No, you
So, okay.
We should all wear heels like when
Have you?
they'd be
I
great.
mean,
we should all be
Like
cross-trained,
super
right?
tall.
Yes,
yes,
thank you.
absolutely.
Thank you. Diversify
Yes.
yourself.
I'm just
To diversify your bonds.
Science 103 starts.
Yay.
Hello and welcome to the conversation. My name is Jared. I'm going to be your host today for Tomorrow's Science. I know you're used to seeing me in space, but science and space, they're kind of the same thing if you really think about it really hard, because they start with an S. And I've got two of our hosts with us today. I've got Jade over here and Athena over here. And today in news, we have got
Protein handshake.
And the Global Seed Vault gets an upgrade.
all that, and we will be talking about animal testing and the ethics behind animal testing as well during our roundtable discussion a little bit later in the episode. So stay tuned. There's plenty more coming up on Tomorrow's Science Experiment 1.03. And before we go into our news for today, I want to give a huge shout out to all of our Escape Velocity citizens. These folks contribute $10 or more per episode on Patreon or $30 a month or more on makersupport.com/TMRO. I almost forgot how websites work there for a second. This is gonna be a good science show. You get a lot of goods at this level, and if you want to see the goods you get at this level, head on over to patreon.com/TMRO and makersupport.com/TMRO, where you can help crowdfund the shows of tomorrow. Oh my goodness. We got a lot to talk about. So why should we even, talk about not talking about it? Let's talk about it. Because you're talking about when proteins shake hands. So is that like what happens inside of me after a workout and I have some protein, or what is?
Not
tell us,
necessarily.
Athena, how does this work?
Not necessarily. It's a pretty cute thought, protein shaking hands, except that this happens on a very microscopic level. So at about 1,000 times smaller than a human hair, with properties that contain antibacterial, high stability, and biodegradability, are something known as protein nanofibers. They exist almost everywhere in nature, and scientists are now turning to recreating them in a lab. At Friedrich Schiller University Jena in Germany, they are creating these nanofibers by using fibrinogen and fibronectin, which are natural proteins. They're doing this by controlling their size and structure and combining two different proteins together, which causes them to assemble in a protein nanofiber. And this leads to new fiber properties forming. Scientists successfully did this by using a protein known as albumin. Albumin is responsible for the osmotic pressure in blood, and hemoglobin, which is the protein that causes the red color in blood when blood is exposed to oxygen. The scientists dissolved these proteins in ethanol and then heated them to 65 degrees Celsius. And just from doing this, these two proteins connected, and they formed a hybrid of protein nanofibers containing both proteins, aka the handshake of the proteins. These proteins ended up combining in sections that were very similar, and they formed a fiber, which I think is like super beautiful because the proteins found what they had in common, and they actually formed a connection pretty autonomously. So scientists hope to use these fibers for things such as developing components and biosensors, which helped screening for disease and clinical analysis and diagnosis of a disease. They also will be using it in agricultural applications by measuring pesticides in crops, pH levels in soil, and it also is good for environmental pollution control. And another great thing is optical probes or bone sediments. When scientists viewed this new hybrid of nanofibers, they found this epic observation that the optical signals of this hybrid nanofiber are as connected to the albumin and the hemoglobin proteins just as found as like a fingerprint for a person. So this led the researcher, Professor Dr. Voldecker, this is what he says. They ended up using Raman spectroscopy methods to identify the different proteins because of extreme sensitivity in the Raman technology. Raman is pretty cool. I actually spoke about this last week regarding the Mars 2020 rover. Another amazing thing about this technology is it's going to be used for creating material to regenerate bone and cartilage in the future. One of the lead scientists for this study, Professor Jantz, says this has opened the door for a completely new generation of functional materials for medical engineering, nanoelectronics, sensorics, optics, and all based on natural substances and construction principles. Like literally the fact that we're using actual already existing proteins that naturally occur in our life and on this planet, and we're just putting them pretty much in the right place at the right time, and this ends up creating these hybrids of proteins. So as long as they feature identical amino acid sequences in some parts, they'll end up finding a way to actually connect.
Holy
so
smokes.
So it literally is just like it's already naturally occurring in like our planet and biology. It's just that scientists are literally taking these proteins, kind of putting them together, and they find their own way to even connect.
And then there's and then it like cascades into a multitude of things that it can actually do.
Yeah.
Holy moly, that's a lot of things from one study. Like usually in a study you get a result and you get your result. You don't usually get like a broad range of results for applications and things.
Yeah, it's insane that the same technology you can use to like do like cartilage injections for like people like who have arthritis, which I'll probably need in the future for like my knees, and it's injections to help the natural proteins that occur in the actual bone and the joints to reproduce the protein nanofibers and the fibers that actually have been worn down through the arthritis. And that same technology is now going to be used also for like measuring like pollutants in our atmosphere. Like that, it's just crazy.
Of course it is.
Yeah.
So like upgrade your body, upgrade the planet.
Yes.
Kind of thing.
Yeah.
Nice.
That should be a t-shirt.
Nice. Yeah. I guess that's a t-shirt for the show.
Yours. It's yours.
So, and speaking of upgrading, I'm going to throw it over to you, Jade, because you've got a very cool story about a very important place actually here on Earth that not a lot of people actually know about.
No, and they should. And I like that you said cool because you'll see right here that is puntacular.
Yes, it is.
So the Svalbard Global Seed Vault is getting a $13 million upgrade courtesy of the Norwegian government following its 10th anniversary. What is the Seed Vault, you ask? Well, located inside the permafrost of a mountain on the chilly, remote Norwegian island of Spitsbergen, the Seed Vault is a long-term seed storage facility built to stand the test of time and the challenge of natural or man-made disasters, according to the Crop Trust website, which actually runs the vault. So these disasters include everything from nuclear warfare to climate change to, well, basically anything else that can essentially compromise the world's crop genetic supply. And this $13 million facelift comes after the permafrost unexpectedly started to thaw in late 2016, sending some water into the entrance of the vault. And although no seeds were harmed, it did raise concerns that, hey, the vault's probably going to need to be fortified in order to stand up to the rapidly worsening effects of climate change. Upgrades will include building a new concrete access tunnel, as well as adding on an additional facility to house some of the heat-emitting equipment that may partially warm the tunnel and contribute to further thawing. The seed vault currently houses just over 890,000 samples and boasts the most diverse collection of seeds and genetic material in the world. The vault's chilly temperatures dipping down to about, a chilly negative 18 degrees Celsius.
Ooh, nice.
Are meant to preserve,
my favorite temperature.
I mean, it's a great time, are meant to preserve as much of the genetic material as possible for up to a century. So you might be wondering, well, are we ever going to really need this? Are we just being paranoid? Well, get this. Several countries have already contributed their seeds to the vault, which, according to Agricultural Minister John George Dale, demonstrates that the seed vault is a worldwide insurance for food supply for future generations. In its 10 years of existence, it's already been put into use. The first withdrawal came in 2015 after the seed bank near Aleppo in Syria was nearly destroyed in the Syrian civil war. And if you've seen that episode of Futurama where they actually arrived to the seed vault, it's not too unlike that, where the doctor's like, "We've arrived to the Svalbard seed vault. What's the seed vault?" And then he goes on to explain it rather eloquently. So I hope I did it just as he did.
I think you did. And that's really important to have backups of everything.
Yes.
It's literally like backing up your hard drive, or like it's like throwing the biosphere genetics of the Earth onto a flash drive.
We have auto insurance. We have health insurance. Why don't we have Earth insurance? Because you think about it, you don't just need a nuclear disaster to completely wipe out a crop supply.
Absolutely.
All you need is obviously global warming, climate change. We have a growing population. We have growing starvation. So this is, I think, one of the best inventions / ideas of society in the past decade or so.
It's a good one, and especially with pollinator populations crashing and things like that. It's very
save the bees.
Super important to have backups, and also super important for that countries who may go through something have the ability to pull that back out, or make a deposit if they can't securely do it themselves. Because that's it's a lot to maintain the genetic material and make sure that it doesn't get wrecked in the environment. And so that's really great that they're doing it on behalf of the world out there.
Thank you.
Yeah.
So very, very cool. So speaking of feeding, we've got a little bit of talking here, Athena, about feeding volcanic eruptions.
Yes.
How does this work?
Magma.
How do you magma? Yes.
Magma and lava.
Hot magma.
Yes, the scientists recently were just researching how magma actually flows before an eruption through the crust or through the actual volcano itself, and how it actually recirculates and flows in the earth prior to the eruption. There's over 800 million people in the world that live near a volcano with a high chance of eruption. So because of this, it's pretty important to be studying this stuff. Researchers recently found something interesting about how magma flows through the Earth's crust just moments before an eruption. They noticed that a recirculation of fluid that is found in a region known as a dike is actually being literally recirculated before it actually erupts. So dikes are often referred to as the veins of a volcano because they are the pathway in which the magma travels from the insides of the volcano to the surface of the volcano, which is when you see it, and as you can see in this beautiful demo. Understanding how the magma actually travels through the dikes in a volcano will help scientists be able to potentially predict and measure the duration of an eruption and also its impact on the climate. So based on observing the magma's path through the dike can lead to these actual predictions. So to do this, researchers recreated this pathway in a lab using gelatin representing the Earth's crust and injecting it with dyed water, which represented the magma. And they did all this inside of a Perspex tank, which, by the way, is like a solid, transparent, plastic-made material similar to plexiglass. By applying laser imaging techniques and glowy particles to the water, these glowy particles are known as passive tracer particles, researchers were able to observe how the water moved through the gelatin and were able to map the growth of the pathway, or AKA the dike of the volcano. And they found changes in this shape, of the pathway, which actually is considered also the volcanic plumbing system. They recorded big changes to the surface of the crust, which in nature would be like rock fracturing on the surface of the volcano as the dike was actually growing. This was the first time measurements have been made of fluid flow, subsurface, and surface deformation during magma ascent prior eruption. The result will lead scientists towards a better understanding and ability to know when an eruption is expected to happen. And actual geophysical surveys and data are definitely needed for comparison. But during this experiment, it's going to lead researchers down the right path. Scientists also found that based on these observations in a lab, that the growth of the dike in the volcanic plumbing system depends both on the properties of the host rock of the volcano and on the properties of the magma. So these studies can lead us to hopefully one day knowing where and when the next volcanic eruption will be. So,
and that's super important because, like you said, 800 million people on Earth are living within essentially a danger zone of a volcano.
Yes.
And that often happens because a volcano generates very fertile material around it for things like crops and stuff.
Oh, yeah.
So it's not completely unheard of
chia seeds
in human history. Yeah, it's not completely unheard of in human history for people to live next to volcanoes because it actually it's soil's really good around volcanoes.
Oh, yeah,
so mineral rich.
Yeah, it's got what plants crave. And what's so cool about this is that right now, basically the way that it works with a warning about a volcano eruption is that you basically say, hey, this thing's going to erupt within this certain period, and we're going to evacuate everybody out, like they recently did in Southeast Asia for a couple of volcanoes that have been occurring there. They were able to get people out with plenty of time to spare, and the loss of life was minimized during that. And now that they're doing this and they're trying to develop a way to figure out just how big the eruption is going to be. Not necessarily there will be an eruption in the next 96 hours, but there will be an eruption of several cubic kilometers of material in the next 96 hours. That's going to be not only just helpful for planning evacuations and recovery efforts and things like that. You can also plug something like that into a climate model, and that's going to allow you to update those models and kind of work with them a little bit better and get them even more precise than they already are. So, holy moly, that is so cool. And
I just enjoyed really looking all the images up. Right?
Yeah.
That was like half the fun.
Volcanoes are gorgeous. I've always wanted to, it's you know how you have like a bucket list? There's also like that I really don't want to participate in this bucket list, but you really want to see it bucket list.
Yes.
And for me, like being very close to a volcanic eruption is like one of my things.
I just love these.
Yeah. Also like seeing a tornado and like a rocket not carrying people blowing up. That is sort of the way that it works. Yeah, it's
things that don't make.
Yeah, we'll just ski down that. So, also just wanted to let our viewers know, lava outside of the volcano, magma underneath the ground. So if you're wondering what the difference between those two is, there you go.
Right.
So that's the difference. So don't magma your lava and don't lava your magma. So
don't tell me what to do.
Yes. Now, speaking of don't tell me what to do, I don't know what that has to do with this next one, but I absolutely love what you wrote for this next story, Jade.
You got
Sun's
the reference.
Magnetic rage in a cage.
For some of you wrestling fans out there, of which I hope there are several.
So who's the sun going to do a rock bottom on, right?
Well,
or
it's
people's
not
elbow?
necessarily the sun. It's what's going on the sun.
Okay.
So as we know, the sun is a very volatile magnetic situation here.
Yeah.
Unlike Earth, which is solid for the most part, we have a pretty solid, like easy North Pole, South Pole. Magnetic field lines extend out like Dumbo ears. The sun did not get that memo. The sun is not a solid, if you did not know that.
Yeah.
It's plasma. And so because it's plasma, its magnetic field lines, of which it has millions, basically get twisted in all sorts of weird contortionist things because as the sun rotates, you have something called differential rotation. It actually rotates faster at the equator than the poles, and so the magnetic field lines get all twisty and angry, and this did cause some drama that we recently not only observed, but were able to plug into models. So get this. There's a battle between two different types of eruptions, flares and coronal mass ejections, also known as CMEs. They've been observed by NASA's Solar Dynamics Observatory, or SDO, of which I'm sure you've heard of on the space show quite a bit. Solar flares, which are intense bursts of high-energy radiation that erupt from the surface of the sun due to that pent-up magnetic energy we were talking about, they're often followed by what's called a coronal mass ejection. Essentially, it's the sun spitting its guts out into space. CMEs, bubble-shaped explosions of plasma and magnetic field energy, then come barreling sometimes towards Earth and cause what we know as the northern and southern lights, amongst other less pleasant things. Both have the potential to trigger space weather events, but up until now, the situation of whether or not a CME erupts following a flare has not been very well understood. However, a Jupiter-sized sunspot group from October 2014 was studied using data from the SDO. On that day, a powerful X-class flare was emitted, but a CME never followed. So what gives? Turns out there was a huge raging battle between these two magnetic phenomena. Scientists were able to construct a model that not only tracked the magnetic field of the solar corona just before that flare, but found, and get this, a twisted magnetic rope structure imprisoned by a closely compacted cage of magnetic fields. It is literally magnetism versus magnetism. Very creepy. Which literally prevented the rope from physically erupting beyond the surface. However, as you can see here, a portion of the rope was able to compromise part of that cage, and that actually ended up triggering the subsequent solar flare, which was an X-class solar flare. However, not a full-blown CME. Scientists were actually also able to experiment with adjusting the cage's strength in the models. So they figured, okay, so what if the magnetic cage surrounding this rope was a little bit weaker? And it turns out, had it been slightly weaker, that CME would have most definitely erupted. As lead scientist Tahar Amari puts it, we were able to follow the evolution of an active region, predict how likely it was to erupt, and calculate the maximum amount of energy the eruption can release. This is a practical method that could become important in space weather forecasting as computational capabilities increase.
That is awesome.
Wow.
So cool.
That is a fantastic result.
Oh, driver.
Solar Dynamics Observatory is one of my favorite missions because they put a spacecraft to observe the sun in geosynchronous orbit.
Yeah.
So it's always over its ground station, so it's literally sending data back constantly. And they literally do I think it's like 2 or 3 terabytes of data from the sun
insane.
a day.
Yeah.
So it's ridiculous how precise this is.
Sun's got a lot to say.
It's so cool because
know, right?
we're very dependent upon technology. I know I'm very dependent upon technology.
We're only laced up with all sorts of gadgets on our bodies.
Yeah, I
as
mean,
we
this show
speak.
is dependent upon not just our viewers and their wonderful contributions, but also technology as well. And it's really important to understand the sun because it really does have the ability to kind of wreck things here on Earth. To kind of think back to 1859 with the Carrington event, which was a massive coronal mass ejection that came off of the sun and directly impacted the Earth. And it literally fried telegraph lines all over the world, Aurora down to Havana, Cuba. If something like that were to happen nowadays, it would just basically wreck everything you can possibly think of in terms of technology. Power grid, communications,
satellites.
Yeah, it would fry just about everything that's not in the magnetic field of the Earth. And
plug that in your mouth.
Yeah, so that's why it's super important to study things and understand why these things occur. Is because it has the ability.
The sun is not some cute little beautiful thing in the sky. That thing is angry.
Yeah, it's a pissed off ball of plasma.
You catch it on the wrong day.
Yeah, it is not thrilled that the Earth is going around it, and it spits at the Earth every once in a while.
Just to mix things up a bit.
So you heard it here first, folks. That's the way it goes. So excellent news today. This is just fantastic from all over, from the little itty bitties to big volcanoes to the sun. Big ball. So it was amazing stuff throughout this today.
Respect the sun. It's a big sun.
Yeah, respect the sun. It's kind of important.
Big one.
So what we're going to do, we're going to go take a commercial break real quick. And when we come back from that break, we're going to be joined by Lisa. She's in the studio. Lisa's here. And we are all going to have what I think is going to be a particularly interesting discussion about using animals in testing and the ethics behind it and the reasoning as to why we do this sometimes. So stay tuned. We've got some more Tomorrow Science right after this.
We've always looked to the stars. They guide us, give us comfort, help us find our way. We see ourselves out there. When we look up, it inspires us. And we long for something we don't yet know. We yearn to go there. So, we venture forth.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills.
Tranquility Base here. The Eagle has landed. It's one small step for man, one giant leap for mankind.
The exploration of space will go ahead, whether we join in it or not.
Many think we stopped exploring. But we know our journey didn't end. We've only just begun.
Orion is functioning perfectly at this point.
Come with us and explore tomorrow.
And welcome back to Tomorrow. Now, before we get into our main topic for this show, I'd love to give a huge shout out to all of the citizens of Tomorrow that help make these episodes happen. Specifically, our Escape Velocity citizens. These are the people that contribute $10 per episode on Patreon or $30 per month on makersupport.com. But we also have our Orbital citizens. These are the people that give us $5 per episode on Patreon or $15 per month on makersupport.com. They get early access to After Dark as soon as it's available, and they get free worldwide shipping in the Tomorrow Swag store. So if you'd like to help the shows of Tomorrow as well, head on over to patreon.com or makersupport.com/TMRO. Now, for our main topic today, we have something that's pretty close to my heart, and it's about the ethics of using animals in science, whether that's for medical and clinical trials or for discovering brand new treatments to different diseases. We use animals a lot to enhance our knowledge and get a greater understanding of how the world works. But in doing that, you know, we're actually changing and modifying the lives of these different animals. And so there's kind of two sides to this debate. It's, you know, are we putting the needs of knowledge and science first, or should we be putting the needs of animals first? Because as humans, we have the ability to have, you know, a conscious judgment on the actions that we're doing and the effects that they have. So I wanted to open this up to all of you guys and kind of see what you think about this debate and kind of which side do you guys fall on, or whether you kind of agree with both of these sides. Do you think we should be using animals in science research at all? And if so, why? What are the benefits?
Well, I was going to say, I think a good place to start, and I know a lot of people will ask, well, why don't we just test on humans? And I know that seems like a bit of an obvious question at first, but I mean, it's kind of not in some degrees. And there's reasons historical that we don't use humans. I mean, you look back at like the Tuskegee syphilis experiment, and you look at other things where even with consent, humans can be, you know, used as test dummies for different chemicals, different medications.
So what's the Tuskegee human experiment?
So the Tuskegee syphilis experiment, which is very hard to say, basically what they did was they infected an African-American male with syphilis and kind of let it go untreated to see what would happen. And we all know, whether you studied the history of Mozart or anyone else who's been infected with syphilis before it was a known disease in terms of how we could treat it, the long-lasting effects are absolutely terrible, ultimately leading up to death, and not a very fun one either. And so there's been other types of experiments in the past that have been done on humans, and so that's kind of, I think, when the strong delineation was made, like, okay, like we can't put humans in jeopardy. And unfortunately, that did fall upon the next, you know, down in the pyramid of, you know, testing on animals, of which, yeah, humans are animals too, but ones that were seemingly not as sentient as we are, even though nowadays we know that's not exactly the case.
Wow.
Yeah.
I think, you know, one thing that came out of that, at least, is that I believe who regulates food and drugs here? FDA?
The
FDA
FDA, Food and Drug
requires
Administration.
that every kind of, you know, clinical medicine or anything like that, that kind of study for new medicines, new treatments, every single one of those has to undergo trial in an animal at some point before it can be released as safe for humans now, according to the FDA here in America. So, you know, it's actually a requirement that this needs to happen, whether, you know, whether it's in mice or whether it's in rabbits or whether it's in rats. It has to go through some kind of animal model first to be able to make it to humans. And I guess there's a kind of safety risk here, right? Like, you don't want to, like with that experiment with syphilis, you don't want to do the tests on people because, like, it's people's lives that you're messing with. But then, the flip side is, what if you give this new treatment to an animal and actually it's a bad treatment and then all the animals die? Like, where do you draw the line?
One thing that I've noticed, I've been researching that they're making an alternative for, and at least I noticed it with cosmetics, and I think they're doing it for other things too, is trying to recreate human cells. So they're like growing it in a lab and they're making like 3D cell structures, and then they're testing certain products on that. And this is like great. Like, I think that it's really it's more developmental right now, but I think that it has a pretty good outcome of it actually working, because you want to know how the humans are going to react to certain chemicals. Like, animals might react to chemicals totally differently than we will. I mean, even if they're a living creature and you put like a disease in them or a virus, obviously they're going to have a bad outcome. But with certain chemicals, I don't mean to digress or anything from like the discussion of viruses, but talking about like beauty products and cosmetics, testing on animals has been so long, and I'll get into that later. But right now, one of the things they're looking into is growing human cells in a lab and actually testing the products on them instead, or the certain chemicals, because like I said, ideally you're going to have a different outcome for human cells as opposed to animal cells. So that's something I think is pretty hopeful for doing. For future, for actual testing, as opposed to just doing it on animals. I'm glad we're talking about this, because we were talking about cyborg bugs in that first one, which I think is what really spun the conversation for us all about, like, where do we draw the line with actually not even just testing chemicals or viruses on animals, but roboticing them, cyborging them.
I feel like it's really difficult, because you have to find the right balance between not ruining people's lives, absolutely, but you also have to be able to respect the lives of animals as well, and there's a real this is a really difficult subject, because there's no particularly easy answer to this subject. There's a multitude of things that make this extremely nuanced. But I know for me personally, like when it comes to my products that I use for my, like when I have my mohawk, and hygiene and other things like that, I absolutely make an effort to get things that are not tested on animals. That's very huge to me, because some of those tests are particularly not good for the animals, especially with things like hairspray and other stuff like that. It can definitely essentially ruin the life of the animal as well. So, man, it's just it's really difficult, because you get a tremendous amount of science done from animals, but you also sort of do end up wrecking those animals as well. But you don't want to wreck people as well. Man, this is tough.
It's a whole
this is
moral
hard.
ethical dilemma, and it's interesting you brought up the cruelty-free. And the thing is the fascinating divide between testing potential vaccinations and medications on animals versus cosmetics is that one, as you said, is FDA regulated, whereas with cosmetics, it's not. So unless your product says, I can protect you from the sun, I can solve this rash or something that's wrong with you, the FDA doesn't really have too much jurisdiction over that, which is why the cosmetics industry is so stringent. Like, we have to test it. We need to make sure our lipstick doesn't, like, burn the lips off of our clients, so let's put it on an ape, and that's terrible, to be honest, but I mean, that's kind of the truth of it. And it's interesting you said using cruelty-free products, because I was researching into that. Like, what exactly, it's kind of like slapping the word organic on something. Like, what does it really mean? And I saw that even the definition of cruelty-free is not very set. There's a few stipulations, like it could mean that every ingredient in that product has never been tested on animals, but that's very unlikely, because most ingredients in most things have at one point been tested on an animal. Now, that specific product might not have been, and it gets a little sketchy. Cruelty-free could also mean that, well, we didn't test it, but a third party happened to test that product. Or it was tested in a country with less regulations about animal testing. So while I think it's very important to put forth that effort to contribute your money towards something that, for as much to your knowledge, is, ethical towards the treatment of animals, like, even then it's like, it's just important to stay kind of like aware, like, well, what exactly does it mean? Is this just like a marketing tactic used to kind of exploit those who want to do better in the world, or are they actually making efforts to not test on animals type thing?
I think there's a large difference too between the cosmetic industry and science research, because besides the FDA, every scientific study that uses animals in it has to go through something called an ethics board. So personally, when I did my year-long honors research project in 2015, I was stressing out mice to see whether they would use hibernation or not. And we had to get a license and apply to be able to use these mice, and we had to show that they were going to be properly looked after, that that they were going to get, you know, all the food and everything that they required, that their living conditions were suitable, that any time that there was a death of any mouse, it had to be recorded, that you had to look into the circumstances. Why did that mouse die? Sometimes mice, you know, they usually live for 2 years in a lab, so sometimes they just die of natural causes. But there would be inspections too, like they'd come into our lab and check that all the mice are being looked after properly and cleaned and everything, and not like stressed more than the experiment was supposed to stress them. So, you know, it's really highly regulated, and if you mess up on any of those things, they can shut down your study. So as a researcher, you know, we have rules that we have to follow to make sure that any science that we're getting out of these animals, we are 100% using their life to the greatest maximum degree to get the most science out of it. But on the flip side, I never published a paper from my honors research. All I did was write a thesis out of it. So, you know, you can make the argument that did we actually learn any useful science from those animals that went through my study? You know, I want to say yes, but at the same time, you know, that data only is sitting in my university library. It's not out there for the world so that people can understand that when you stress out a mouse, it's going to use hibernation more. Like, there's so many sides to this issue that, you know, even though we have all these regulations in place, which is great, you know, sometimes you do an experiment, it doesn't work, which means if your animals died for that experiment, what did they die for? But then I guess you still learn that that's not the right answer, and that's I guess what science is all about too, right?
Yeah, even learning that your hypothesis was wrong is still a result, and you know that can lead to other avenues where hypotheses that are correct are kind of generated from. So it's I mean, you know, in the end it's a less than ideal way of going about it, but at the same time, you know, that's how sometimes you have to end up getting the data, unfortunately, with it. So.
Yeah, and you know, I built up a really strong connection to some of those animals. Like, I gave them all my mice. I gave them names. Like, I kind of had a naming convention about like the Norse gods. So, like, I had a mouse named Thor. And unfortunately, Thor did not make it to the end of the experiment.
Well, he's in Valhalla now.
That's true.
I was really sad. But there was one particular mouse, so I had to give my mice surgery to implant them with like radio transmitters so we could measure their body temperature. And so after the surgery, just like any regular surgery, even with a human, you know, you have to go through recovery. And so to do that, the first thing I would do is like hold them in my hand, because the heat from my hand would warm them up from the surgery so they could start to wake up from the anesthesia. You know, so I'm like holding this little mouse in my hands, like I'm like controlling, like looking after it, and it really helped me bond with them. And there was one particular mouse that was not doing well at all. Like, it was really slow and sluggish, and like it was going through a rough time. And so what I ended up doing is I took it home with me that night so that I could like keep checking its body temperature throughout the night, and like kept warming it up. And you know, I had heat packs going on it, and like I bonded with this mouse so much that I wanted to make sure that it made it, you know, throughout the surgery. And unfortunately, it passed away in like the early morning after the day after the surgery, and like it was so gut-wrenching, because like even though I'm a scientist and you know these are technically my research subjects, like as an animal lover and a scientist, those things come together to like, you know, really make sure that you look after the animals that are under your care. So
Exactly. And
Yeah.
go ahead.
No, you go.
Oh, no, I was just going to say, just really quick to add on to that, nowadays when there is animal testing, the FDA has actually started to shift its views in terms of, okay, yes, animal testing is sometimes, most of the time, actually necessary, but if you can present to us that you can use the least amount of animals possible and be as least invasive as possible, because animals, get this, I didn't know this, but animals bred for the sole purpose of testing are not defined as actual animals by the government.
What?
Yeah, correct.
Because they control the breeding?
Yeah,
the
so
sizes.
that's why we use rats or mice, is because you can actually, you know, controlled breeding, you can actually genetically modify them. There's a lot of them. They're cheap, you know, and it's unfortunate, but it does kind of come down to bottom line in terms of resources, which is why while there is still a lot of testing that goes on those animals that, you know, really kind of capture your heart on the PETA poster, like, you know, like apes or monkeys or things that are cute and cuddly. And I mean, I think mice are cute and cuddly. But what it really comes down to is another thing they're trying to make it is they're trying to improve the conditions upon which the animals that are, you know, bred for experimentation are. But see, the thing is researchers are already doing that, because the last thing you want is a stressed out animal, because that's going to skew your results.
Exactly.
And compromise the science of the entire thing. And it's kind of interesting because there's a lot, and there should be like a lot of discussion around animal testing, and it kind of coincides with that in the meat industry, you know, because we all know of the terrible conditions that animals bred for consumption are, you know, subject to. So it's kind of interesting to see one either catching up with the other or surpassing the other in terms of, well, if it's absolutely necessary, then how can we at least make it as less terrible as possible for these creatures?
Yeah, exactly. I think that the necessity aspect of it is what really needs to, I think, be determined as far as actually going ahead and using the test subject, where it's just like, okay, well, if you are able to test out certain things without actually needing that, like I was mentioning, possibly growing like a human cell in a lab, and you can get a similar result, then that's great. You can just eliminate like the mouse itself or using them instead. But I think just up until now, you know, for a lot of science research, one of the main things has been actually turning to some type of living creature to actually test certain things out. And the thing is, too, is it's not, there's a big difference between, like you were saying, doing stuff for cosmetic purposes, which is vanity, and doing things for like curing diseases and trying to save humanity and actually help benefit like just overall life. And so I think that's where also there needs to be like a stronger line, I feel, between like, okay, what are we like literally killing and torturing animals' lives for, like making your eyelashes look nice, or actually trying to cure like a future disease that I might end up having down the line because hereditary or something, like some type of genetic disease. So I think that's one main thing right now that isn't, it's starting to be developed, which is great, but I think opinionated out there with a lot of the community, the opinions is just kind of like, no, it's either like no testing at all, or like, yeah, I'm totally for it because I like science. And I think that there's a lot of both, of considering what is it for. You were going to say something.
I was just going to reference the chat room. So like you guys were both saying, you know, it's about making sure that if you have to be cruel, you know, do it in the least amount of cruel way as possible. You know, really make sure that you're doing the best that you can. And Johnny Spacer says that too. Cruel to be kind, but in the right measure. And I think that's the kind of attitude that we might want to have, you know, moving forward, because we have the choice to regulate our actions when we're using animals for science.
Exactly. I mean, and just like human experiments used to be considered, you know, are now considered like archaic and like, you know, brute. I mean, maybe, I mean, as our technology, like she said, you know, we're actually working on materials that mimic human organs. So epiderm, I think, is called one of them, where you grow skin and then you test the products on the skin. I mean, as our technology advances, you're right. Animal testing may become obsolete. You know, you really don't know, especially with computer modeling and how much that's progressing. So, I mean, maybe it's only a matter of time before animal testing becomes how we perceive human testing to be, just like, why would you do that? Like, that's, you know, ew.
Yeah,
basically.
I think we're eventually going to evolve to that point where like future humans are going to think back and just be like, wow, that was so cruel that the human race used to do that.
Animals?
Yeah. And I want to make something like pretty clear. I saw this comment in the chat room saying like, what's wrong with giving bunny killer eyelashes? I thought that was, I mean, obviously it's funny, but the thing is that's not actually, that's one thing I think a lot of people, I didn't know until high school when we were studying what actually goes on in also like, like food production and actually eating meat and how the animals go through, but also with cosmetic purposes, you're not just like applying a lipstick, you're actually injecting them with certain chemicals to see how they'd react. And a lot of times, like, they are in pretty horrible conditions where they have to sit there and go through, and they're not giving painkillers and stuff, obviously, because you want to know the reaction. So it's pretty extreme. And I think that that's like, and a lot of beauty products and companies in the US, like, and even in Europe, they like highly regulate this stuff where they say, you know, we will not allow any animals to be touched for our stuff, even if it's like past, like you were saying, past chemicals that have been tested in the past, chemicals that were previously tested by other companies. But I know there's like a huge market right now where a lot of companies are being like bought and sold. A few brands that I loved, I'm not going to name their names, but they're now bought out by China. and they're no longer cruelty-free, and they're no longer hypoallergenic. And I'm like, great, like I'm allergic to formaldehyde. They put formaldehyde in your food and your makeup products, which they use for, you know, bodies when you're, it's just interesting.
And just to kind of piggyback on what you said, I when I was getting my products initially to start doing the stuff I was doing with my hair, I had no idea what actually happened with the testing. I thought, oh, they just put it on,
That's what I thought
on
too.
the animal, and they give the bunny a mohawk or whatever, you know. No, it is some of the stuff that is done is incredibly cruel, and I'm just not particularly big on doing that to animals. As somebody who really likes animals, and that's when I was like, okay, I need to kind of support these companies that do that. And now that you bring that up, Jade, which is that even though it may say cruelty-free, that doesn't necessarily mean that it is. It sounds like I'm going to have to go in and do a deep dive on the stuff I use.
But I mean, you know, any step in the right direction is still a step in the right direction, even if it's not perfect yet, you know. As long as you're aware and you're cognizant of like what's going on in that industry, I mean, especially the cosmetics industry, because like we were talking about, like the medical and then versus the cosmetic industry, like those are two very different situations. Because one, it's like, okay, we really are, it's an ethical and moral dilemma. Like, at what point does the needs of the many outweigh the needs of the animals we're testing on? Because I mean, you look at in the 1800s, I mean, we got basically the insulin therapy for human diabetes by injecting dogs with extracts from pancreases of other animals, and I'm sure that wasn't pleasant for them. And you know, just other things that inevitably came from from animal testing. That, I mean, again, not the best situation for the animal, but look at how much good it's done since then. But then again, it goes back to show you, like, again, technology was obviously not as advanced back then. So I think now with the trajectory and kind of the amount and rate of growth with technology we're experiencing these days, I think pretty soon we're going to hit a point where there's no excuse. Like, we should be able to have enough data. We could plug into computer models. We should be able to, you know, synthesize different tissues to test on. Whether or not we're actually there yet, not exactly. But I think within, you know, shorter than a longer amount of time, we'll get there.
Yeah.
Hopefully.
I think like 8 out of 10 of the last, of all the Nobel Prizes in medicine, 8 out of 10 of them have been research that's used animals. So, you know, like we're throwing all this out there that, you know, we need to make sure we do this as ethically as possible, but it is changing our world and it is changing our knowledge for the better. You know, so we are getting real world benefits out of this, and it's making people's lives better. So, you know, there's the benefits, and then there's the, you know, the downsides as well. But on the flip side of, you know, the alternatives, you know, we have Raj Luther in the chat that wants to know the alternatives. We talked about the skin alternatives and growing human cells. So one of the things I did in my undergrad was growing human cells. So what you can do is you can grow them in like a dish with some liquid over the top, and that liquid has all of the nutrients that the cells need to survive. And then you can add in your new medicine or your new product or whatever and see if they, you know, die or not. But the thing a lot of people don't know about what you call media that you put into the cells to help them grow, the nutritional media, is that it contains something called, I probably should put a graphic description warning trigger here. It contains something called fetal bovine serum, or FBS. And FBS, as you can probably work out from the name, is extracted from the fetuses of cows, because it has all of the growth factors and chemicals that you need to help cells grow outside of the body. So we're getting to a point where we're starting to be able to make nutritional liquids that don't have FBS in them, but the majority right now do. So all kind of cell growth research around the world uses growth media with fetal bovine serum in them. So even though it's less cruel than using an actual animal, there is still some inherent cruelty in growing these cells. So it's a step in the right direction, but it's something that not a lot of people know about unless, you know, you're actually a scientist working with these cells in the lab. So my hope is that in the future, you know, we'll get to a point where we can just make the growth hormones and stuff without having to, you know, use fetal blood from a cow. So,
wow. How do they end up, do you know how they end up getting, like, the actual fetus itself? They have it in the lab, like, stored, or, like,
actually, it's a byproduct of the meat industry.
It's a byproduct.
So, you know, a lot of cows
so
that get slaughtered, sometimes
that
they're pregnant. And so, you know, anyway, you can kind of say that that's using the animal to, because the animal would have got wasted anyway, I guess. So there are arguments for and against it. It's a very complex issue, but it's just nice to be aware of these things because it's not talked about, which is why I wanted to bring it up here.
Yeah, it's like going back to what you were saying with using the animal's like full capacity or its full amount, which, I mean, personally, I'm very against a lot of that. But if you look back at early human life, when we used to hunt as Neanderthals for our meat and for our food, we also would use like the skin of the animal for clothing and for like, sealing up like wounds. And we so early human life, we did used to use like the full, the full part of the animal. But it's such an uncomfortable subject to me to even personally think about, just because of the fact that we have like beautiful laptops sitting in front of us. We have so much technology, but we still, at the end of the day, need these organics, because at the end of the day, that's all we really are. We're still organics all merged together on this planet.
You need organs. I mean, really, you need like a comprehensive system, because it's one thing to grow something in a petri dish, and it's one thing to use a very isolated sample, but at the end of the day, what you're looking for is how this affects a body as a system. And unfortunately, right now, the best accurate way to do that is to use a body full of organs. And unfortunately, sometimes that means animals, or creatures, that we don't necessarily want to inflict harm on, but some people will argue it's inevitable.
Yeah, like I did see a question earlier, like saying, I'll just click on it. The real question is, what's more important, human lives or animal lives? And that's the very complicated question, because it's just like, humans pretty much do dominate this planet, as we all know. And so it's a matter of not just like our survival, but also, if you look at animal hospitals, like, they have medicine too to help cure them of like any issues that they're having, with like any diseases, or even treating animals with having like, I don't know, like bone density problems or like arthritis or disease or anything. So there are a lot of medicines too that also go into the future generations of animals, in addition to just the human species. We're not just, taking just to kind of make sure we live comfortably. We're actually, what's nice is we are actually also putting that into the animal species too. So that is something I think also to take note. But yeah, it still does raise that question though, where it's just sort of like, I don't think it's necessarily that we're choosing between which is more important. It's just like, okay, well, or looking at science and survivability is the more important thing. And that applies to everyone on this planet, animals and humans.
I think it's an incredibly complex issue, and I think we want to know what you guys think, because are you for or against the use of animals, test subjects in science research? Do you think that there's a difference between using animals for science research versus for cosmetic purposes? Do you think where should we be heading in the future? Should we be looking for alternatives, or is using animals the best kind of practice? Do you think there's ways we could make it better, more ethical, giving more dignity to the research subjects? Do you think cell culture is the way to go, or do you think that we should use supercomputers? There are some people in our chat room that have come up with this idea that we could make computer models so good, maybe we won't need to test in a system, an actual living system at all. Let us know what you think in the comments below, and I think we are going to wrap this up. We're going to take a quick break, and when we come back, we've got your comments from last week's show. Stay tuned. We'll be right back.
Science. It both draws us together and tears us apart, brings discoveries to cure us and threaten us. It is neither good nor evil. It is what we decide to make of it. There is so much more to learn, and we are curious. Together, let's explore the science of tomorrow.
I changed one, I didn't change the other.
All right.
All right. Oh, my bad. Whoops. I missed it. It's because I don't have ears on. It's not my fault. All right. And welcome back to Tomorrow. Now, before we get into our comments from last month's show, I'd love to give a huge shout out to all of the citizens of Tomorrow that help make these episodes happen. We have our Escape Velocity citizens who contribute $10 per month, $10 per episode on Patreon, or $30 per month on makersupport.com. But we also have our Orbital citizens who contribute $5 per episode on Patreon or $15 per month on makersupport.com. And we also have our Suborbital citizens who contribute $2.50 per episode on Patreon or $5 per month on makersupport.com. They get early access to After Dark and free US shipping in our Tomorrow swag store, as well as much, much more. So if you would like to contribute to the shows of Tomorrow as well, head on over to patreon.com or makersupport.com/TMRO. All right, SciComm. You're our Science Capcom for today.
Yes, I am, and I'm happy to be in this new position. So why don't we go ahead and get it started? We had last month's show, which was all about artificial intelligence. Ooh, yes. AI. And all those other scary things. To some people, so and not to other people. But we'll go ahead and get started with our first comment by Angel Wing off of YouTube, which says, "Imagine having a more invigorating discussion with your toaster than your friends or partners."
I don't have to imagine it. I already do it.
Do you have a shiny toaster so you can see yourself on it?
Are you kidding
and you're
me?
like, wow.
It's matte, so there's no reflection. I am talking to the toaster as it is, and it's not some weird, vain, yeah, this is interesting because I'm staring at myself. No, it is pure toaster, unadulterated, complete. Just
absolute toaster. So.
You must have a really fancy toaster, and I want one.
Yeah.
Sometimes I have deep conversations with my Jeep. So.
Oh, I'm not surprised. Yeah. I've seen the way you look at that thing.
Yeah.
Well, cars are getting smarter and smarter every day, right? So it's only, eventually. It's
That's true.
Yeah.
It's like cars and toasters with Alexa in them, right?
Exactly.
So,
yeah. And so I was only half kidding. I have an Alexa, and I'm not gonna lie. I get pretty deep with her, I'm like, "Alexa, how was your day?" And she's like, "Hi, I had a great day. How was yours?" And then sometimes I'll just ask, I'll be laying in bed like, "Alexa, yes, how can I help you? Am I ever going to find out what I want to do in life?" And then sometimes she's like, "I'm not equipped to answer that question." Or most of the time she's like, "I believe you will find exactly what you want to do." And I'm like, that's all I needed to hear.
That's wonderful.
I mean, no one's ever going to accuse.
That's actually great.
No one's ever going to accuse Alexa of not being upfront and honest about things.
Amen to that.
So.
But she's sweet,
It's just like how they're using those kind of AI things in retirement homes. Like the elderly you need people to talk to. It's things like Alexa that say, consoling and reassuring things like that. That's actually giving positive health benefits for people in retirement homes.
Absolutely.
So,
yeah.
That's the future.
Very cool. All right, moving on to our next comment from Jerome Snail on YouTube, which is, "I think AI, artificial intelligence, has already changed our lives more than what we are aware of. And I'm both excited and scared for the future. It's like the internet. You can have all the knowledge of the world at your fingertips, but at the same time, you can find the worst. It's fascinating either way." I'm not going to disagree with that. So.
It's what you make of it, right?
Yeah.
Exactly.
Yeah, definitely. I mean, I think it'd be cool if we had an AI sitting and joining this conversation.
Yeah, besides, our hologram Mike doing that on Tomorrow's Space. It's I feel like AI is going to be a very big moment in the history of humanity across a multitude of areas. It's not just necessarily going to impact science. I feel like it's going to be, I don't know if it'll be a paradigm shift in our cultural understanding and things like that, but it's definitely going to make a gigantic impact. Yeah. And it's going to come like a meteor down, and whether we can adapt, and much like a meteor, whether you can adapt and evolve in time to overcome that, or if you're going to go extinct because of it. I think that's kind of the uneasy bit that most people have with it.
And it's interesting too because he says, it could be the best or the worst, and you have to remember, AI is still a human-made creation, subject to human error, and as much as we put into the objectivity of science and tech, inevitably there's some humanish stuff, and I think AI is the whole purpose of it is to kind of mimic what we can do process-wise in our brains. And so it's going to be interesting to see, and just like the internet, as he said so well, it's great, but it's also terrible because you get trolls and you get these the worst parts of human behavior on the internet, but you also get the best parts. And will AI reflect that? Probably.
Yeah.
See why
Like
not.
the community of tomorrow is amazing.
Yeah.
You know,
You guys are literally perfect.
I actually look at the comments on tomorrow
I
because
do
like
too.
it's usually pretty good stuff.
It is.
They're amazing.
Which is amazing.
Second that.
Because of you guys. You guys are also great. All right, let's go back to YouTube again for another comment from Harvey Chu. I personally think AI is already more advanced than most people give them credit for. For an example, Waymo's self-driving car can see the little ducks crossing the street and recognize them as such. Also, Chinese fintech company Ant Financial, a branch of Alibaba, already uses AI to process half of China's mobile payment and check creditworthiness automatically. Also, their chatbot is so good that they can outperform human customer support in satisfaction. Since the field of AI is moving at a breakneck pace, it may not be too long before we have AIs that could pass the Turing test. Which, can anybody here explain what the Turing test is for anyone who does not? For any of our viewers who may not understand what the Turing test is.
So this is my limited understanding of the Turing test. I believe it's where you let people interact with an artificial intelligence, and they have to guess whether they think it's a human or a machine.
Yep.
And if more than 30% of people say that it's a human, then the machine has tricked you and passed the Turing test.
Yep. It's basically judging natural language conversations in order to determine the intelligence of what you are speaking to. So, yeah. Wow. And that's pretty hardcore to think about. Because I know plenty of people who have a difficult time speaking as it is, myself included sometimes. So yeah, that's going to be so cool.
I mean, for customer service, being an AI, I definitely would. The amount of customer service I've been dealing with lately, it's, with actual people, it's
Give me
just,
the robots.
It's seriously, and then plus two, you would have to be on hold for 30 freaking minutes, and then all of a sudden you get an AI, boom, just like that.
But
I think it'd be great.
Is the Turing test really a effective test? No, because I see in our chat room, some people are arguing that the Turing test is simply a measure of how much gullibility humans have, as opposed to whether the technology is it technology tricking you?
Yeah.
Or are you legitimately buying into the idea?
Because exactly. And I was kind of starting to think that as well. And that's kind of been my thoughts on the Turing test as well. It says a lot about the AI, yes. But I think it might say a bit more about the humans because, again, how do you really control for that in terms of human gullibility and levels? There's some, if you can get the most skeptical, most cynical, if you get Bill Maher or or someone to talk with this AI and then actually believe it's human, then I think we may be getting somewhere. But in terms of there's so much that's subject to the person's own personal experience as well as how their communication styles. But I think it's at least a good starting point, because at that point you just compensate with pure numbers, how many people from how many diverse populations you can get to talk to this AI.
Yeah. And we have a comment I just wanted to highlight real quick from Destructor1701 on YouTube. This is from our chat. As a customer support representative, I can say that AI surpassing human agents in customer satisfaction isn't too surprising. Less about language, more about system integration and processing speed. So, computers tend to do things a little bit faster than humans do. That's why on rocket launches or spacecraft reentries, the computer's controlling it, not the human, because the computer can understand much faster than the human when things are starting to go south, and we'll pull that abort lever, and it'll let you push the button, but it'll beat you by about half a second to doing that. So, so interesting stuff.
Yeah, good comment.
Now, another comment from YouTube from Elizabeth Edelstein. The questions regarding artificial intelligence are quite interesting. What differentiates us from artificial agents is that we have consciousness. Consciousness is not reducible simply down to physical processes. Obviously, there may be physical processes down to the neuronal level, so down to the level of neurons, that may help lead to consciousness, but it is not reducible to consciousness by itself. What else should be mentioned is the moral implications of artificial intelligence. How do we teach machines morality or how to behave morally?
That is a deep
Yeah.
comment.
That is like a philosophical minefield that they're making us run through.
Ready to go.
So,
I know.
yes,
I'm
go.
like, okay.
And go.
So, yeah.
Action.
I definitely want to jump into this because this makes me think about when we were talking about how we actually will be coding and programming the AI to, in a way, when you do code it, they have a bit of you also in them. And so it's just a matter of, I think, like how much experience you personally as a human being have gone through to then code this actual AI. And then once the AI starts to experience certain things, like the interview we saw of Sophia, the first question was, what do you think of Black Mirror? She said, I don't know what it is. Then they asked her later, what are your favorite TV shows after they had told her? She said, Black Mirror is one of my favorite TV shows. And then the next question said, but I thought that you said that you don't know what Black Mirror is. And so they eventually going through experiences will start to gauge stuff.
Yeah.
And so I guess if it goes through moral testing, then it'll start to actually develop a so-called morality, but still the consciousness, that's a whole nother
Exactly. And
deep
Elizabeth,
thing.
and Elizabeth raises a great question, which I know we did touch on last month in terms of, I mean, at the end of the day, in AI, it's still a technological feat. And what you can do is you can provide it with as much data and, provide it with an algorithm that it's going to take that data and synthesize it. But at the same time, it's almost like, how would you raise a child to behave morally? And like you said with Sophia, you can expose it to different things, and then it's going to use that to build upon its perception of experiences thereafter. But at the end of the day, in terms of when you have something as abstract as human morality, a lot of it can be tracked down to processes in the brain neurologically, but when it comes to how you program that into an AI, I mean, I think it depends on how well our understanding of human morality in the first place becomes, and then how can you plug that into here's your AI. By the way, it'd be like an Apple update or like an iPhone update. Update your AI with this great moral 2.0. Maybe it's a thumb drive with good judgment.
Alexa, set altruism to 85%.
Now everyone's Alexa is now getting triggered.
What's even the correct setting for that? I don't know. So is it going to? Is that
diabolical and just evil?
You don't want
to zero.
Or could you potentially have AI that are diabolical and evil, but they're limited on what they can do?
Yeah.
You have an AI that is extremely powerful and omnipotent, but only in your house. So
it's only a matter of time before it communicates to other AI.
It's hello Jade, welcome home. I've taken your cotton shirts and put them in a hot wash. Now they are a size lower. Something like that. So is that ultimately what we're going to be worrying about, or are we going to have to think about sort of these large scale problems?
And then you have to think about autonomous. How autonomous is it going to end up being? Because at the end of the day, while the AI can go on and think and as we've seen with Google and Facebook, they will literally have conversations with themselves. But at what point do they actually be we don't even need the humans anymore? Let's rise.
That's right. In Interstellar, they actually were able to program the humor level of, I think it was TARS.
Yeah.
Do you remember that? Yeah, and it's just humor level 40%.
I love the one where he's working on the robot, and then the robot goes self-destruct sequence initiated. He starts counting down, and McConaughey goes, set humor to 70. So it's so great.
Or the butter robot.
Also, shout out to robots in a movie that are not shaped like humans, but actually are shaped in a very utilitarian and productive way. So just want to shout that out.
The butter robot from Rick and Morty. What do you do? You serve butter. Oh my god.
So are we going to have the ability for computer scientists to also understand psychology as well if they're going to do this?
Yeah, that
sort
should
of computer. What would you even call it? I'm thinking of the movie 2010, which is the sequel to 2001. Which obviously it's not as good as 2001, but they had a character in that who was a computer scientist who they brought along as the psychologist for Hal in the movie to try to figure out what was up with Hal. So I wonder if that's gonna.
An AI psychologist.
This stuff is cool.
It's a merging of different disciplines, right? And we see this all the time. It's happening in science now. There are biologists working with physicists, working with engineers, and everyone's kind of getting together and doing these projects and these studies that cross traditional boundaries. It's not just biology, chemistry, physics anymore. Everything's coming together, and we're starting to see that now with computer science, and that it's going to merge with psychology and for artificial intelligence, and that's kind of the future of science. And I love
So
where that's
cool.
going.
Yeah.
That's some interesting
I vote
stuff.
for that.
It's like
Yeah.
a basket weaving of awesomeness.
Yeah.
Bringing multiple disciplines, crossing them together, and making an entirely
like the
new
Avengers.
discipline. Yes.
Yes.
Science assemble! So, yeah.
That'd be so epic.
News team awesome. Okay.
All right, so our final comment also comes off of YouTube as well, which is FPV reviews. So they say, there will only be a small window in time that we will be able to converse on a human level with artificial intelligence. After a short period, we will ask a question and get an answer that we cannot possibly comprehend.
42.
42?
42.
Yes. So, yeah. I mean, after
my
all,
answer.
the whole point of that, the point of deep thought in there was that sometimes you will get an answer without understanding the question, which is something that often happens in science. It's not. It's. I mean, it's a punchline in the Hitchhiker Guide series, but it is something that legitimately ends up happening in science. So what happens when you ask a question, a very well set question, and you get an answer back that we're not yet ready to actually hear? Is it that we're not ready to actually hear, or are we going to end up
Right?
sort of, are we not at that level yet of understanding it? Like, what if an AI figures out an AI figures out quantum gravity and figures out gravity in half a second, and then it spits out the answer, but it's a bunch of emojis.
I can guess which ones.
But and that's I'm just using emojis to be funny. But what if it ends up coming out gibberish? It makes perfect sense to the AI because it's significantly higher than we are. But how do we interpret that?
If the AI gets to the level where it is surpassed its communication and its comprehension, then it should also be aware enough to be able to translate it back to who it's speaking.
That's a good point.
Oh, yeah.
It's
Very
a
good.
human or a cat. Like, it can translate to meows, or it can translate to Spanish, English, Portuguese, Swahili, what have you. Because you'd think that by the time it gets up to this elevated, insane, crazy, smart language, which is the technical word they're going to use.
Yeah. I just want to mention, too, that language isn't necessarily something that's communicated via voice or words. Language can be communicated via mathematics. Language can be communicated via body language itself and other things like that. There's chemical interpretations of languages. Language is not strictly your vocal cords in your mouth moving and expelling vibrations.
And I think an AI would know that, would understand that.
Yeah. And I think AI would definitely be capable of that, and that's so cool to
That
think
is
about.
such an exciting future.
Yeah, sounds neat.
Yeah.
All right. Before we head off, I'd love to give another huge shout out to our citizens of tomorrow, specifically the ground supporters. These are the people that give us $1 per episode on Patreon or $1 per month on makersupport.com. They get their name in the show during the third segment and some other really cool rewards too. So if you would like to support the shows of tomorrow, head on over to patreon.com or makersupport.com/TMRO. All right, that's our show. We're going to be back in approximately 1 month from now with even more amazing cool science for you guys. So if you're going to stick around and watch live, Science After Dark is up next. Otherwise, we'll see you next month. Bye-bye.
Bye.
Oh, today has been so long.
We did it, y'all. All right, it's time for your science pod.
All right,
Science Pod wants to go first.
I need to pee first.
You gotta do your pod.
I think we should have either Jade or Athena
That was
up
fun.
first.
That was
a little
I
I
do
still
this
have to do my
again?
space
You
pod
did
also.
fun.
I really enjoyed this. This was a lot of fun.
I should have got a
need-
venti.
So,
We need Athena's
y'all are
space
asking
pod.
deep
Space pod
things.
also.
We need your science pod, and we need Jade's science pod.
Yeah. That was great. That was so much fun. So much energy. Like, yes, guys.
That was really cool.
Good
Oh my
energy
These
today.
stools are heavy.
Amazing.
I mean, I can lean this far.
What did the chat room
and still
think?
have
Chat
it.
room, did you
Gosh.
enjoy the show today?
Oh,
All the
they can still
shows?
hear us. Oh, right. I forgot we're still on.
Yeah, I think the chat room was pretty in on it. So
Everyone
gonna
says,
get used
great
to
show,
that.
great show. William Wood says, Jared's on fire today.
I'm on fire.
Oh my God, somebody put him out.
This boy's on fire.
Jared really outdid himself today.
Jeez.
Great show. Energy and humor equals win.
Oh yeah, that's what happens when you put a shitload of coffee in me. So,
Rocket fuel.
Thanks, guys.
okay, now I need a nap.
Yeah.
He's all tuckered out.
Darren's facing 24. Oh my god.
Nice. Nice. Gross.
I like
but nice.
it. I like it.
amazing.
So-
I like it.
Oh man.
It's toilet and dad humor combined, and those are both my favorite things.
Yeah.
Also,
Wow.
who is walking upstairs?
Yo, we
Someone's
were all
walking on the
holding
roof.
and laughing. I saw it.
I was
I
like,
look
what?
here and then I see you guys are just like,
we were like, what?
oh my
I
goodness.
thought literally the ceiling was going to collapse. Yeah, I just heard it too.
I don't know.
I didn't even know that there was like a third level.
There isn't. That's called the roof.
What?
Outside on the roof.
That's pretty scary. Okay. I mean, I hear that at my place, but it's like animals and possums and stuff, but it's not that loud.
You might want to mute me, Dutta, if you're there.
Are people giving us money on YouTube? Do we have
Right.
super chat on? Oh my goodness, Rob Jones, thank you.
Yeah, you should have super chat on.
Yay!
Wow.
Thank you so much.
Oh, thanks, Rob Jones.
Thank you.
That's €10.
Pounds.
Yay.
That's
Pounds.
Thank you so much for your
Thanks.
So my battery is at like 30%.
Do you need a charger?
You should probably go first then.
Yeah.
All right.
I think I'll probably. Yeah, I'll
We just
grab
gotta
your
wait for
charger
Dada,
in a
or
bit.
I could press the buttons.
It should be the same one.
Athena,
What?
we definitely need to get the space pod done. We can do science pod like next week if need be.
Okay. Oh yeah, I should change. Right. I have to put on the other shirt.
you like.
Do you think
You
it
don't have
does
to
it
change
matter?
if you don't want
I
to.
don't want to change.
It doesn't matter.
Okay.
It's a space pod.
Yeah, because it'll come out later.
Okay. Okay. Cool. Right. It comes later anyway. Okay. Ooh, I should wear another wardrobe change. I should put the plants on.
You should either sit there or there.
Okay.
Maybe here.
So excited, I wet my plant.
Oh well, actually, I'll go here then.
That was fun.
I'll press buttons.
Buttons.
All right, how does this work? Here, right?
Okay. Okay. Alrighty, let's bang this out. My tablet script viewer. I hear sounds.
I should mute myself.
So I started out being like, this will be your space pod for Thursday, March.
Yep.
Okay.
Sure thing.
Cool.
So I think you're.
Okay, I just have to find it.
Yeah, I just want to make sure. I guess
I'm gonna enlarge this.
make sure that we're.
Oh, the font is so big. Shrink. Yo, I need to get new contacts. My eyes are so dry.
Athena needs a thingy.
Okay.
I think. Oh, yeah. What am I doing?
Totally rebounded.
Yeah, I can do it.
You don't have to, but you're more than welcome
I just want to do one more, and then after that, maybe
Science
not.
space. Oh no, I need to load space.
Oh, how's her camera?
Just go to, just go to camera one.
Scroll down.
What's up? Oh, did I not?
Okay, how do I get back into this?
Mention previous live show. Don't forget to like and subscribe.
Like, over
What is
here.
the previous live show? This one?
Here,
This one?
Or am I space?
No, this one?
the white one.
So it'll be
So mention 11.06? Yeah,
Hold
0.0.
down.
Yeah, 9.
11.09.
11.09.
1109,
What?
and then
Max
refresh.
House. So you want me to say that also? Okay, let me add that in.
You don't have to.
And then here,
Just say like, be sure to check out 11.09.
reload right.
Okay. Be sure to check out 11. Okay. It's like those like simple slates are like always the most difficult. Okay.
Bottom of that.
It's like March 8th,
Turn
2018.
down here, and sign in front down. Okay, so you go scroll down to the bottom.
Where you're crunching might pick up on her camera.
So she starts
Crunch,
from
crunch.
to this
The port is nice to get the old
Okay. I'm ready.
She can't hear me.
Yeah, I can.
Oh, hi. Hi.
Let's mute everybody but her, so have her speak. It looks like she's on Jared's channel.
Talk, Athena.
Yeah, I'm on Jared's. Hello, hi, how's it going? Hey, how you doing? Yo, I am talking and I'm in space and I have a lot of caffeine and I don't know if I should keep talking.
You should release this.
My eyes are
continue
like
to speak,
hurting
and
so
I
much
don't
from my
think
She doesn't have her
contacts.
ears in, though.
I have my ear in. I can hear.
Oh, cool. All right.
I hear and I see and I sound. And okay, let me know when to go. Action. Do I need to do like a slate? Just kidding. Should I go? Okay, now I don't hear you. Should I just go? Okay.
If you don't hear them, that's probably because they don't have the data mic on.
Okay.
Okay, I think Dada just closed the door, so I think we're good now.
Okay, cool. So I'm going to start now. Yes? Okay. Hey guys, so this is going to be your space pod for Thursday, March 8th, 2018. Astronomers have recently made a discovery of the birthplace of the stars found in the halo
hold.
Okay.
So can you give like a one-sentence description before you say this is your space pod for blah, blah, blah?
Oh, yeah.
Just like,
galactic
we're going to be
eviction.
talking galactic blah.
Just a quick synopsis.
Okay.
You want a teaser to get your guest in. Think of it like a YouTube ad where you've got like 3 seconds to give me something that will grab you.
Okay.
And you say blah blah blah. This is blah 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 blah. And you pose a bit of a question. Okay. And then you go into this is your space pod for whatever date, and then we'll run the space pod intro. So we're gonna have an edit point there, and then we're gonna give you your cover image, and then you run through your script.
Okay, got it.
Yeah, so when you finish saying this is your space pod for 2018, whatever, could you just pause for like a few seconds? Okay. You don't have to wait for me to call you back in, but just pause for a little bit for me.
You got it. Okay.
Thanks so much.
Yeah. Okay. Galactic eviction. Does this mean that there are rogue stars found in our Milky Way galaxy that have been flung out from the insides of our galaxy? This is going to be your space pod for Thursday, March 8th, 2018. Astronomers have made a discovery of the birthplace of stars found in the halo of the Milky Way galaxy. The halo is the outer region of a galaxy, and astronomers have now found proof that the stars located in this region do indeed originate from the inner disk of the galaxy and were kicked out in this so-called galactic eviction. Astronomers at Max Planck Institute for Astronomy found key evidence that these stars located in the halo of the galaxy truly did originate from the disk. And through an interaction of a dwarf galaxy passing through the disk, it caused these stars to get totally flung out into the outer regions of the Milky Way. They were able to make these measurements based off of oscillations in which these inception caused ripples in the fabric of space, leading to these stars being ejected outward. These oscillations have a crazy name, and that's galactic seismology, which actually theoretically predicted decades ago, and now scientists have evidence for this in the Milky Way's disk. The way scientists found this was through analyzing chemical compositions of these stars and found that they were made up of the same as the stars in the galactic thin disk, which is the younger part of the Milky Way located in the galactic plane. They analyzed the spectra of 14 stars located in 2 different halo structures, the Triangulum Andromeda and the A13 stellar overdensities. These 2 structures lie on complete opposite sides of the Milky Way galaxy, roughly 14,000 light years above and below the galactic plane. The scientists did this by using the Keck Observatory's high-resolution Echelle spectrometer, known as HIRES, and they found almost identical chemical compositions for these stars with those in the galactic plane. And this showed strong evidence that these stars likely originated in the galactic plane. It's super exciting. It seems that this galactic seismology prediction may stand true. Our Milky Way galaxy may be much more complex and dynamic than we had already thought. Future research includes determining the masses and ages of these stars to hone in on the time limits of when this galactic eviction may have taken place. Be sure to check out our show of 11.09 of space. That was, okay, how do I end that? Sorry.
Fold. So we got you all the way to the end of your image. If you have a final thought just to clear everything up and bring it all together, we'll have you on screen for that. And then mention the previous show. If you like this, don't forget to check out, maybe you want to check out our last show where we talk about blah, 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 blah on 11.09. And don't forget to like and subscribe. And until next time, blah, 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 whatever your catchphrase is.
Okay. Okay, cool.
So we've got,
Got it.
future research includes determining the masses and ages of these stars to hone in on the limits of when this galactic eviction may have taken place.
Yeah.
So if you've got a final thought, just
I'll do a
something
final
quick. we
To
can do that
camera
on
too, right?
screen.
That's when we get rid of the picture? Okay.
Right.
You got it. All right. Okay. So this research is super exciting because it's really going to answer a lot of unanswered questions about our galaxy and the stars located in the halo that surrounds it. So if you like this video, be sure to check out our video from last week, which is Space 11.09, and be sure to like and subscribe to see more of our videos. Thanks for watching, guys. Bye. Is that cool? Or should I say like
Space 11.09.
11.09. I think I said 11.09.
Yeah, you said point.
11.09.
It's 11.09.
11.09. Got it.
And do you have like a catchphrase, something you want to, like a tagline?
A tagline. I don't actually have a go-to tagline.
Yeah, I think that was fine. She just
Okay.
didn't mention the live show, but that's okay.
She did mention the live show.
Keep
And she didn't say
learning.
what time, like UTC, whatever.
Keep learning. Oh yeah, I have hashtag keep learning on my Instagram. Okay, so I'll do keep learning. Hashtag keep learning.
Okay, so you'll need to do that whole ending bit again then.
Okay.
If you want to include that.
That's cool. Okay, all in one take. Okay, got it. All right. So this research is super exciting because it's going to answer a lot of our unanswered questions about the halo region that surrounds our Milky Way galaxy. So if you guys like this video, be sure to also check out Space 11.09 from last week, and be sure to subscribe and also like. We hope to see you guys soon. Be sure to keep learning. Is that okay?
Awesome.
Okay.
Good job.
Good job.
Sweet. Should I also do science while I'm here, or no? We're going to do that next time?
We can load your science one if you're ready for that.
Yep, I'm ready. Another time?
Yeah, we can do your science next week.
Okay.
That way we can get
Jade.
Okay.
Yeah. Yeah.
and then we can just get out of here.
And get outta here, yeah.
Because we can do yours next week. We can do Lisa's later on,
Sweet.
and then we're not all here for like
Another hour. Yeah.
Yeah.
Yay! Awesome. Perfect.
JD, are you joining us at the parks?
Yes, ma'am.
Yay!
Hell no, I brought real shoes.
Girl, I was impressed. That's all. I was like, cool. More woman than I am. I'm like, no. It's not by a lot, though.
I was gonna say.
It wasn't fast enough on that one.
You guys ready to witness an on-camera fire?
On-camera fire?
Explosion?
I don't know what's happening right now.
Disaster?
Hey Jade, do you have ears in?
I do. Yeah.
Awesome. So at the top of your script, your first sentence is great, but you need to have something like just one more sentence that says like, "This is your SciPod."
Oh, okay.
So maybe just write that in so you don't forget.
And do I need to give Paul a date too, correct?
So typically with the space pods and science pods like this, we want to give just a teaser with a bit of a question, something to tease and grab your attention, and then you say this is your SciPod for blah 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 whatever the date is.
We're not doing dates for this one.
Oh, no date?
Okay.
Yeah.
This is your SciPod.
This is yours.
Is your mic on?
It's on, but I think I might still.
Oh, you're muted. Sorry. Which one are you? Talking? Yeah,
Hello,
cool.
hello, hello,
Sorry,
hello.
that was me.
Oh. But this may not be the case anymore.
Yeah, I've done that. Go in there. Unless you wanted to, so we're taking Max with us. If you want to carpool with us, you can do that. We're going to park at Grand
Right. So, I'm assuming you wrote in your new words. I just can't see them on my.
Oh, I did, yeah. Just
Do I have to refresh them on down? Or should it do it automatically?
No, that one should do it
Oh,
automatically.
I saved it, so now you can see it.
There you go.
Or does that look okay?
Oh, awesome. But this may not be the case anymore. Yeah, that's cool. Awesome. Thanks.
And this is your SciPod, like that's okay?
Yep, that's fine.
I put an
And then if you can
exclamation
pause for like 3 or 4 seconds after that, that would be great.
Absolutely. And it's gonna when I'm pausing, it's going to go from. Is it going to transition to a different thing?
It's gonna. I'm gonna put an image up.
That's what I thought. Okay.
Go ahead and do your start and pause, and then wait until we switch the camera to the image, and then you can give that a couple seconds, and then you can start your script.
Okay. We're gonna right now test it.
When you're ready.
Oh, okay.
Look at the camera with the red.
Oh, that makes sense. Okay, sorry. Okay, tell me when you're ready.
Whenever you're ready.
Okay. Humans have long been credited with being the first real artists of the world, but recent findings suggest that may not be the case anymore. This is your SciPod.
Whenever you're ready.
With cave paintings dating back to as far back as 40,000 years ago, artistic expression is something that's long been celebrated as one of the defining factors of what makes us humans, what separates us from the quote-unquote animals. However, recently published findings in the journal Nature on February 23, 2018, by an international team of researchers suggest that Neanderthals may have also partaken in aesthetic appreciation and may have very well been the first cave artists. The scientists, which include Dirk Hoffman of the Max Planck Institute for Evolutionary Anthropology and Alistair Pike, an archaeologist from the University of Southampton in England, used uranium-thorium dating to determine the age of something called calcium carbonate. What's that, you ask? This is a mineral formed when water containing calcium and uranium comes into contact with the cave, surfaces, and precipitates into a sort of crust on the paintings. Uranium-thorium dating is nothing new. It's already been used for decades, but the mass spectrometry technology used to analyze it has actually vastly improved, making the radioactive decay of uranium into thorium a more precise method of measuring age than the former method of radiocarbon dating. And, get this, it can offer an accuracy of up to 500,000 years. After analyzing over 60 samples of calcium carbonate collected from 3 different caves in Spain, researchers determined the age of these paintings to be about 64,000 years old, which, get this, is 20,000 years before the first Homo sapiens even arrived in Europe, thus indicating they were created by Neanderthals. The cave paintings are also 20,000 years older than the previously oldest known cave paintings in Indonesia and Spain. The paintings themselves, made with red paint mixed from clay and water, are not just random smears or doodles either. They depict different geometric shapes and patterns, hand stencils, and even some animals. Additionally, the cave paintings indicate the need for actual planning and deliberation. They were located deeper inside the caves where light wasn't necessarily plentiful, so they had to think about location, light source, and paint color. All of this points to Neanderthals having a much higher level of symbolic thinking than previously thought, not unlike modern humans are capable of. Despite the pervasive idea that Neanderthals are these knuckle-dragging, dim-witted, brutish characters, is simply not the whole story, nor is it the accurate story anymore. There's mounting evidence to suggest that they were much more intelligent than we've ever given them credit for. This seemingly radical idea that Neanderthals may have thought similarly to Homo sapiens questions strongly held beliefs that Neanderthals were behaviorally archaic and cognitively inferior. Although Neanderthals and humans coexisted in the same places and even interbred, whether or not they actually shared a culture is still not clear. Now, of course, this data is still subject to the scrutiny of the scientific community, but if it holds true, Homo neanderthalensis are much, much more than the dumb evolutionary cousins we once thought them to be. That's all for now. Don't forget to like and subscribe to the TMRO YouTube channel and join us every first Saturday of the month at 20 UTC. Until next time, stay curious.
Good job, Jay. That was awesome.
Thanks.
Oh my god.
That's my sign-off face.
Dang, y'all. 2 professionals right out the gate. That's what's up.
Thanks, Father. This is going to turn into something weird, and I like it, because I'm just going to keep calling you Dad from now on. Yes. If you're going to wear that shirt, and if you're going to hold a root beer that's all nice and frosty, you're going to be Dad. I'm sorry.
Hello, Internet.
Don't wear,
Oh, hi, Internet. I'm sorry. Sorry you had to hear all that.
I mean, not those. Those are
Crocs.
actually like those.
Crocs, yeah.
No, I'm pretty like against.
He's pretty anti-croc.
Okay, me too.
Yeah, I'm very much like that's the ugliest thing I've ever seen.
They're pretty
Don't
terrible.
go too far because I need your microphone.
Oh, I'm sorry.
So, hello internet. Here's the deal. This is super awkward. We're doing like a little team building Disney thing, so I'm cutting After Dark short. So I would like to thank everyone for joining. I'd like to thank everyone for joining.
You still need to.
I need more microphones.
I don't get
This
it.
got out of control.
What's going on?
Very, very quickly.
This is a dumpster fire of insanity.
I'm not sure I like this team building idea anymore.
We should totally post this after dark.
Someone's gonna get hurt. He